say. None of it's matter of fact. It's all stuff that just is a result of my, cumulative knowledge and preponderance, stuff that I, am very fluid on, and I'm always evolving these ideas, to try and add, some meaning to the community and, what everybody's setting out to do. Try to put things in perspective, maybe give different examples of, how some of these different super complicated theories and ideas come together in the bigger picture of things, and how that might apply to the project that you're doing, in your engineering designs and so on. And, just overall further your knowledge of some of the effects of the forces at work when you're doing your coil building and so on. So I don't necessarily think or believe that I'm 100% correct in any of this, but it's stuff that I like to share just to always keep the, the brain cells on point and firing for everybody. So,
yeah, you say that, but usually it all comes out pretty good when we have other people on and they start verifying what you're saying. It all makes sense.
Yeah, a lot of it does make sense. And, I think where it becomes interesting and where I start to it's not even doubt myself necessarily as much as it is, realize as the thought process on it evolves, and it goes into different areas, the implications of what that ultimately means. And, and you'll understand what I'm saying in just a minute about that. So, I'm going to take an extremely complicated topic now, and I'm going to oversimplify it to the point where it's almost comical. I think that's sort of the best way to put it. So this actually goes in tune with something I was discussing with Nathan the other day. In fact, it was a discussion with Nathan that brought about this thought of kind of how to describe something, and that kind of culminated in the need to want to have this episode. So I want to just say that it all follows the formula that I previously discussed in other videos, the same exact chart that is the descent of energy to matter. And we're going to be elaborating on a lot of that today, right? So what I want to think about is how it all started, okay? And again, oversimplify it, but then tie it into how it's relevant to what we're doing, all right? So here we have this white plane, a white piece of paper, okay? I know it looks not white on camera, but this is a blank white piece of paper. There is nothing on it whatsoever. Okay, and suppose for this example, it is still, calm, and it is both a piece of paper and not a piece of paper at the same time. It's just could be. But then on this piece of paper, what we're going to do is draw one single black dot. Oh, wow. Yeah, can't see that.
That light's got you. There you go.
Okay. Maybe that's a little bit better. It's still terrible.
Oh, it went dark again.
Yeah, you get the gist, though. So now you have one dot on a white sheet, okay? Now, there is a lot more white page than there is black dot, okay? And if not for this black dot, what's the relevance of the white sheet? Okay, now this is the creation of duality. All right. Now, this white sheet, it just wants to be a white sheet. So what it does is it goes after the black dot, and it tries to erase the black dot. Okay, but the black dot, it's not going anywhere. So it battles it out. And what it finds is it was able to make a little bit of progress breaking down this black dot, and it was able to break it down into this sort of less black gray area. Okay. Now, the white not wanting to be anything other than the white sheet continues this. It disperses this black dot into just a bigger and lighter gray area until the whole entire page, suppose, okay, is gray. Now, once the page is gray, okay, it can no longer be a white sheet. Okay, it cannot get rid of the black dot, and it has in essence reached a form of equilibrium, becoming a gray sheet. Okay, now how this is relevant is after the start, okay, this white page, for purposes of our use, okay, as human beings on planet Earth, trying to do anything with our environment, okay, this white sheet is damn near irrelevant to a degree when you're talking about physical matter, okay, because there is no matter in the white. Okay, the black represents the matter in this, okay? So, but now that it's formed this equilibrium of gray, okay, where it's balanced out with the matter, energy and matter balanced out, okay, that is the point of access for a usable Aether field, okay? Now, what becomes very interesting, if you want to continue this thought experiment with the gray paper now, okay, is you may look at this paper from a distance and suppose it was just entirely gray, okay? But if you zoom in, I don't know where my camera is, all the way, you realize that realistically that gray paper, that solid gray paper, is really just areas of some gray, some black, some white, just all in close proximity to each other. So the battle never really ends, okay? That battle just went from this macro state to this more micro state. And why this is relevant is this, okay? There's 3 states that exist on this gray plane, realistically, okay? You have an area, a locality, as we've been saying, locality, right? You're going to have localities where the density and presence of matter, okay, is stronger than the force and pressure exerted in that area by the energy upon it, okay? Then there's going to be other areas where matter is far outweighed by the energy that's present in those areas. Okay, now this is going to become super critical because what ends up happening is what we've talked about before, but now it kind of gives a little bit more rhyme to the reason here as to why there's mass consolidations that occur. First at a very small level, then on a growingly large level, then at a more macro level where you have a molecular structure to matter. At that point, it's 3D matter. At that point, molecules bonding to form elemental, particles, and then those forming to create elements and compounds. That's sort of what you're looking at, is this buildup then of the matter. Now, the more matter that's in a particular area, in relation to the energy acting upon it, okay, the more dense it becomes. Now, where it becomes very interesting, and it goes back to what we were talking about planet formation, okay, is this explains the planet formation, okay? Like when you're talking about relationship of energy and matter, and considering that the sun is a form of energy. So that puts that into context. But now when you look at what's interesting, and it seems so common sense and obvious, but it's very nuanced, okay? If you think about the uninhabitable planets that are uninhabitable because they're desolate, okay, versus Earth being a habitable planet, versus gas giant planets which are not desolate, Okay, there are a lot of things. They might not be inhabitable, but they're not desolate. And then you start looking at, well, what's that mean and why? Okay, that's where it starts to get very interesting. Okay, and it plays a major role, not only of basic processes that we know here on Earth, okay, but how special Earth really is, and how that also complicates some of the things that we're trying to do when it comes to manipulating energies. And that's where this is ultimately headed, if we're following the train of thought. All right, so first let's talk about desolation. Okay, desolation and decomposition, material decomposition by virtue of energy, okay, is realistically what you're looking at when you're looking at desolation. Okay, if you have a ratio, okay, where you have an amount of mass being subject to a disproportionate amount of energy, so the energy is overwhelming the mass, okay, that energy is going to break down the atomic structures of the compositions of that mass. Okay, and it'll do so until basically at least the part that it's able to react with, like call it the surface, but it could be all the way through depending on what the constituent materials of the mass is, you know, and what how much energy is being exerted. Okay, but that amount of energy is going to reduce the original mass composition from a more complicated form of compounds to its most simple form of depletion. Okay. Now, I mean, what do I mean by that? Well, basically what energy is going to try to do is by virtue of plasma. Okay, it's going to try to break the hydrogen bonds with everything that it comes into contact with. Now, hydrogen makes up 75% of the universe. Okay. It's present in most compounds that exist. It could also go further than that, okay, because there's, aside from hydrogen derivative compounds, there's also harsher elements that, when exerted to high levels of, you know, radiation, could ultimately transmutate through plasma streams, okay, and in these plasma streams be deconstructed to their simplest forms, being ions and electrons, creating free hydrogen. Now, if you have a system where the energy is so overwhelming to the mass, okay, it's going to create a ton of hydrogen. If the energy continues to overwhelm the mass during this hydrogen influx, during the desolation of the planet, okay, that hydrogen returns to an energy form entirely. So let's bridge the gap, okay? We've talked about electromagnetic fields how many times? Every episode. We've talked about plasma how many times? Every episode. Okay. We've talked about the difference in, you know, states. Now, what do we know about plasma? Okay. Plasma, they call, you know, a fourth state of matter. Okay. It's a little misnomer. Okay. Because what we have to understand is that the chart that I spelled out, where the white paper gets disturbed and then falls into all these other things, okay, all the way back up to matter, that is not a linear, you know, definite thing. It's a spectrum, okay? And at the top of the spectrum, you have energy like, okay? And at the bottom of the spectrum, you have most matter-like. Okay, so all the way at the top, plane is most energy-like. All the way at the bottom, most matter-like. Now, everything in between starts to gradient between it. As you go down, it becomes slightly less energy-like and more matter-like, and vice versa. So when you're talking about plasma and you're talking about hydrogen, okay, at that point, you're talking about plasma, which is a matter-like energy. Matter-like energy. Okay, and then you have hydrogen, which is an energy like matter. Okay, and that's really, really key. Okay, because anytime you have either no hydrogen, no atmosphere, no hydrogen, and you have desolation, it's because the energy overwhelmed the matter, depleted the hydrogen, and left whatever was left behind. Now, if it really overwhelms it, it could melt it. If it really overwhelms it, it could start to create other secondary reactions that'll continue, which we'll get to a little later on, because that becomes more relevant. In the key of desolation, it's really just hydrogen, sucking the hydrogen out. And then ultimately, once you've broken everything down to hydrogen, and then it doesn't have enough density, that's the key, is this barrier. Okay. We think of the magnetic field. The magnetic field of Earth, right, protects us. It's a misnomer. Okay, it's a misnomer. It's not that it doesn't. It's that the way that I've seen it described, okay, is as if the magnetic field was a propagation of Earth. Okay, I don't believe it is. Here's the reason. Because you have Earth and its mass, okay, and its atmosphere. And as that atmosphere diffuses and it reaches a point of diffuse, okay, where there's on one side energy like matter, on the other side matter like energy, plasma, okay, which you see all the time at the poles constantly. Other external things can make it more apparent, the visual plasma. But what do we know about a plasma field, Nathan? Is that when is it most effective?
When the plasma field most effective?
Yeah.
When you're not using the plasma.
When you're not, right. So when there's no visible to the eye plasma discharge, but there's a plasma field, that's when it's most effective.
Yes, absolutely.
Okay. So the way you know it's effective is that you don't have an aurora borealis over the entire Earth. Okay. That's how you know it's really in play. So now you have this borderline, this war zone, the pressure equilibrium of where the diffuse energy and the diffuse matter, okay, meet. Now, if you wanted to create a magnetic field, all right, what do you do?
All you do is put electricity in a coil of wire.
Okay, so in the simplest terms, you're going to expose an electrical current to a mass.
Yeah, basically.
Okay, so although the propagation of the magnetic field, okay, is of the Earth, because the Earth is the matter, the same as the coil is the matter. The energy in which it meets at this pressure equilibrium threshold is the manifest of the magnetic field.
Yes.
Okay. What is the observable nature, okay, of increasing the power through the mass coil, and in the context of a coil? What does that magnetic field do?
What goes on the magnetic field?
Yeah, I mean, if you run more power through a coil, what's the result?
It just gets stronger.
It gets stronger, but visually, the magnetic field tightens up. right? Well,
okay.
that's when you deal with solar flares and solar events, that's the observation of our own magnetic field. That's why I'm saying that Earth's magnetic field is a misnomer. It's not Earth's magnetic field. It's
yeah, but the Earth pushes it out, and then the rest of the solar system pushes it back.
Which is the pressure differential. Exactly. So when you have these bigger solar events coming in, the increase in pressure exerts on the system.
And it forces
the system, runs that system harder. It also keeps Earth from diffusing out into nothing too.
Well, it also forces the amount of electricity that the Earth puts off in that field to push back on us. It's not necessarily that, we're getting more sun. It energizes that field even more, and then it affects us more.
Perfect. So why are we alive on planet Earth? And I'm not talking about this is non-esoteric. Plenty of time for that if we wanted to go down that. But why are we on planet Earth? Why is there life here and not in the visible universe as far as we know? Like that's just that simple and abundant. The answer is they've oversimplified it, and I'm going to overcomplicate it. See how the system goes? Sometimes they overcomplicate things and I have to simplify it, but other times they just gloss over things and then it becomes a bit of a misnomer. They say that, to simplify it, we're in a life sweet spot. We're in a life sweet spot. Well, equilibrium is a good way to look at what a sweet spot is. Sweet spot just doesn't really, it's just nondescript. It doesn't really say, well, why is this a sweet spot? I mean, it has to do with the fact that there was enough sunlight to cause the reactions that I've discussed, but not to the extent of desolation, and also not to the extent in which we'll go on when we talk about the gas planets. Okay? Because what ends up happening is, first of all, in order for Earth, in my opinion, don't really know, but hey, good guess, I think. In order for Earth to have reached the equilibrium, okay, we had a hydrogen atmosphere at one time that was doing the same exact battle that all the other planets were facing, okay? But because it was controlled, okay, and because it wasn't it was producing the hydrogen as fast as it was taking it away, okay? The transmutation that takes place in that process led to heavier elements, primarily helium and oxygen, okay? And then once there was an abundance of oxygen present, the world set on fire. The entire world burned. And when it was done burning, we were left with water and stability. Because what we effectively did at that point was this hydrogen, okay, that could have as easily have become energy again as it could have became matter, okay? It became matter and locked up, all of the energy like matter that is hydrogen, okay, in a form that could be used, okay? It could be used because water easily evaporates. Then the bonds of the hydrogen and the oxygen are broken up during this evaporation. Now all of a sudden you have all this free oxygen. So now you have plasma working against oxygen, creating ozone, heavy oxygen, ozone, blocking the full penetration of the energy. That's how you build the atmosphere out of that and neutralize or not neutralize, but reach a point of equilibrium where this world is not more matter or more energy, it's both. And it's the both characteristic of it in that equilibrium that can exist, that then harbors a symbiotic relationship between matter and energy, which is ultimately the manifest as the animation of matter over time, because if you think about it, there's still depletion going on. Well, but there's not enough to deplete it to the center. So things developed in a way that, this energy wanted to escape, and this energy was there, and it was within this matter. And it did so by trying to circuit itself out, but to no avail, and then again, insert religious belief, spiritual belief here. But scientifically, that to me makes that logical, progressive sense.
So let me throw something out at you, okay?
Sure.
We talk about the fields on the earth, but the sun also has fields. So if you take the sun, obviously inside of it, but then when you get outside of it, you still get spherical energy that comes around it. So it goes out. So you would say that the point right before you hit Venus, there'd be a strong point. Then it would weaken a little bit. And then as it gets right past the, not the Kuiper belt, but the asteroid belt, you get another field. And then it hits Jupiter. So Jupiter would gain a lot of energy being so close to it. But then inside the middle between those two fields, you have Earth, and you also have Mars. Now, Mars isn't experiencing a whole lot of energy in it right now, but Venus is. So Venus has to be closer, just like Jupiter is, to that field. So, and it goes out further and further each time. So I think part of the one thing we'll end up finding out, maybe not in our lifetime, but in somebody's lifetime or God's lifetime, that as soon as we get close to the field, we pick up energy, and that if we're in the middle of the field, we're in the sweet spot. Now, that could be also between the outside where Jupiter, before Jupiter, and then beyond that, there's probably a sweet spot in there, but the energy's less. So it's like rotating a magnet. You get a field, and then there's drop-off points, and then there's another point. But this field has a pushback to it. And because it has a pushback to it, that point where it dropped off normally is actually energized even more. That's my thought on the solar system. And we're going to find that there's a field around the entire solar system because of the sun.
Oh, well, there is, just because of the locality interactions of matter and energy within the solar system, and the fact that we have an energy output in the middle of the solar system, hence why it's a solar system. It would definitely, like that greater diffuse, and plus all of the matter in it in interaction would have a field of its own. Absolutely. I mean, what's the significance of that? I mean, that's probably like a little rough to say. Obviously we are then in a galaxy, with other solar systems. Solar systems do come into play with one another. Albeit I have looked into that before just to see what the dynamic of that is. And it seems to be a phenomena that they know happens, but they never have. They have only been able to capture what they believe is the aftermaths of it, and not the actual event itself. Obviously, I think that would put a lot of perspective on what the outer shell of the solar system is, because seeing that interaction, but at the same exact time, as above, so below, to understand that interaction, scale it down, And although you might not have a full simulation of what it exactly would be, you could understand a lot of the dynamics at work.
Well, I think as well, when you start having belts of asteroids or Kuiper belts, it means that it ran into something it couldn't get through. So there might be an energy there that is not so harmful to little ships, but is very harmful to planets. You know what I mean? Because it changes the energy in that planet, and it'll either overexert it where it explodes, or you know what I mean, it'll let it pass through. And I think that's what's going on in those two belts right there. And then one other thing I'll let you talk is the outside of our solar system, because it has a bubble, there has to be something pushing against it in order to force it to be there. But then if there's another solar system next to it, there's another bubble. So anything that interacts with that outside bubble of our solar system would bring energy back to our sun. So depending on what's out there, it could impact the whole entire solar system and give it seasons. So when I say seasons like that, I mean like, you know, we're going to the age of Aquarius, then we go into another age. You know what I mean? And
absolutely.
That's probably their calendar of figuring that out, is they knew that there was something out there with an outside pressure to cause more on us, to give us those things.
Right. I mean, if you look at how celestial maps and eras and epics and so on were always broken up, it's always from the perspective of Earth, okay, but it's always looking further and further out, you know, into the greater equation of it, you know. So you're dead on, in my opinion, with that. It's there's absolutely you know, the same as the Earth has seasons within our solar system definitely has galaxy related seasons, and our galaxy probably has, you know, universe related seasons as well. You know, and with just the effects to us from our lens on Earth being more and more subtle, you know. But sometimes these subtleties, you know, if it's significant enough of a change, you know, in either direction, you know, it could really manifest as like a cascading type event, which is something that I definitely wanted to talk about, you know, too. Was
well, let me freak everybody out right now.
Please.
If all those things are there and we know about them because they were written in literature a long time ago, who wrote them? How did they know they were there? How long would you have to live in order to see that in your solar system? Because it won't happen in my own lifetime. I won't see every one of those. But somewhere somebody saw it and could put them all together. So they did it in the past as well. So did we live longer then? Was there somebody coming to our planet to show us that? How did they figure it out? Where they knew what
right? Isn't that so? So that's where this gets super duper interesting, and it depends on how woo you want to get on it. You know, it's and me, I'll take it all the way to the, you know, to the end. Me, like, I don't care. Like, I'll consider it all possibility until we know otherwise. You know, right? Ancient. This stuff comes from old texts, and it's been around for a very long time, and it's really being you know, rediscovered now, because I think people are starting to open their minds a bit more to you know, some of the heresies that were struck down in the past. You know, we're not going to go down that road with this conversation. I'm stopping myself. All right. You know, right. So you have these ancient literatures. So does that mean that it came from, you know, the Anunnaki? You know, did it come from them? Did it come from other visitors? Did somebody enlighten us to this? Were we just inherently here with actually all of this knowledge, only to have it lost over time? Something maybe not the most considered of the reasons of lost knowledge. ever think that we just knew it from the get-go and we lost it? It's what the Bible says.
Yeah.
Right. Then there's the idea that, well, we've made it this far in such a short amount of time, and knowledge, wisdom, and technology are not necessarily one and the same. If we look at a civilization from the perspective of a modern lens, and we look at a people, in that are Aborigines or something, you look at them and you call them primitive people, and they're primitive because they don't have the society that we have. They don't have the technology that we enjoy. But that's not to say that their energies and efforts weren't into figuring out something greater than all this without all that,
Right.
So is it possible that in the past, they had higher knowledge of these things because that's where their focus was? And, it just wasn't of importance or concern to them or priority to them to utilize that knowledge in a way that is similar to what we consider high technology, high advancement today. So, right, you could build this pyramid and that's what you're spending the time on, is this pyramid, and this is your means to an end, to take the knowledge that you have, the ideas that you have, and put them into practice for a certain cause. But you know what, like the friggin' plasma TV or the LED TV or whatever, like, why do we need that? It didn't even occur to us, because why do we need that?
Right.
Yeah.
Well, I agree with that perspective, and it goes into kind of how to make natural energy out of the earth versus what we're doing now. Taking an acoustical chamber, putting some kind of crystal in there, energizing the crystal, getting some piezoelectricity going, and then we have a natural way to make the energy versus the unnatural way that we're doing it right now. And it would be more in harmony with Earth than what we're doing.
Absolutely. And, that ties right into the symbiotics of it all. The funny thing is that all this high tech stuff that we do, all the mining operations, all the, chemistry and material sciences that go on, although I really like that sort of stuff just because it exists, cool. But, but all this stuff, like when you think about it, it's all of detriment to the symbiosis of the planet. Okay, it all is. And it's also more steps and more processes to undertake, to potentially achieve the same means that could have been found naturally. And what's ironic about that is the more natural or simple the design of something to accomplish your end goal, the easier it is for it not to be discovered, in the future. It blended in with the landscape. It was made of the landscape. It was the landscape. And then you have an event and all of a sudden it's indecipherable from something, that we look at and we're like, it looks like a spoon, but yet it wasn't ever a spoon. It was actually a tuning instrument, because our minds are not applying the context that maybe it was being used for. And that's a great possibility. In fact, it's more reasonable to believe that, that than it is really to believe that we've made it this far in the most complicated way possible. Like that's it.
Well, part of the thing is I think we've always had the tools to get where we are now. It's when we stop letting people hold us back is when we actually start to get where we need to go. And I think that's one of the biggest things that I have a problem with when you see everybody in kind of this kind of community. They like to put rules on things, and they like to tell you the same thing over and over again, and they'll recite a book to you about those rules instead of saying, well, let's just do it our own way and then we'll let others judge whether the rules apply or don't apply, because there's cases where they do and they don't, and then there's reverses in experiments, and you don't know exactly why. But I think it's important that when we go forward as a society, we take down some of those rules and maybe just have them as a guideline. Maybe that's okay as a guideline, but it's not okay to force somebody down because you think it's a rule. And I think that's important to keep in mind when you do this kind of stuff.
That's the mantra of my life personally. Like it's you got to live and let be, and you have to. I think I said it the other day when we were on with Gerald. I was trying to kind of give a visualization for some people as to how my mind personally works, because I mean, listen, I don't think it's the greatest mind out there, that's for certain, but what I do think is that it's always open to new ideas and always open to changing and looking at things that different way that may make all the difference in just the overall expression of either what I believe to be true or how I'm going to act, like all those different dynamics. And I think what I had said to Gerald was, if I'm going to use a metaphor to kind of describe how my mind has always worked, and I never understood it until much later in life. Okay. And it makes sense why. My mind works like all these different individual puzzles. Mm-hmm. Okay. Just you have 100 puzzles. And whereas most people, when they're making a puzzle, they're going to go right for all the edge pieces because they're easy to identify, easy to find. And if you put together the edges, generally speaking, the rest of it falls into place pretty simply. And, once that puzzle is done, well, this is what I know. Now I have this done puzzle. My train of thought has always been a lot different than that. It's been find the edge pieces and throw them in the garbage. Build the puzzle. You get as far on that puzzle as you possibly can. And just keep on working on all the puzzles, and eventually what you see is that it was never 100 different puzzles. It was just one big puzzle, and by keeping those open edges and realizing where the other puzzles end up connecting to it, that's the key to an open mind. That's the key to an open mind, because once you put the edge on the puzzle, nothing connects to it anymore. That's it. It's closed.
I look at it like we build spheres. We don't build squares. That's just the way I see it. We build things in 360 degrees. We don't build them in a cube. We don't live in a cube. We live in a sphere. So you cannot have straight edges in that sphere. It just doesn't happen.
Same concept, different way to describe it. That's all it is, and most things are. And most things are. It's why it didn't make sense to me when I was a lot younger was because I had all these different pieces and I made some connections, but they just seemed like their own puzzles still, but then once you made that first and second connection, then you realize, wait a second, what else goes together? And then it starts to just quickly, sometimes very quickly, abruptly falls into place. It immediately changes your perspective. Yes. Immediately. Once you make the realization that that's sort of what it is. But I know a lot of people that, in life, in themselves and in their practice, they walk a very defined line. Very defined line. Oh, no, it's not supposed to be that way. It's supposed to be this way. And if it's not that way, then it's not good. I like to look at that as like a resiliency issue, and I love words, and resiliency is I think that's probably one of the most important words in the English language because it describes so much. It's something's integrity to keep up on its own weight, but still be hammered and put and weighed upon and be deformed and still manage to stand. It's malleable with integrity, and that is an incredible thing to be, because that means that you could take the blows, you could take the blows, you could be wrong, but you're still standing, and that's it, and the crazy thing about things that are resilient, they can also be hammered back into shape.
Yeah. Well, one of my favorite experiments that's going on right now is when Sean took that Tesla coil, I put it into a ball instead of just a straight tube. And the reason for that is because the energy that comes out of it's different. Normally the energy that comes out would interact with any crystal cylinder that you put next to it, and it'll start sparking on it. You'll get a beautiful light show, right?
Mm-hmm.
This thing actively, now that it's in spherical shape, it actively avoids it. So it has nothing, it will not interact with it, which means it's probably pulling in the energy instead of pushing it out. Mm-hmm. So just by changing the experiment that nobody's done, I've never seen it before he did it. And when he did it, it changed everything completely. So it kind of goes back to the Earth thing.
Is this something you can share, Nathan?
Oh, yeah. I've done it several times, and we've done a whole Friends Think Tank on it.
I might have missed it.
I'll bring up the thing in here in just a little bit. I'll look for it.
If anybody's new to this, there's hundreds and hundreds of hours of content. So, if you're into this sort of stuff, strap in. I haven't even consumed it all yet,
So the thing okay, so he's got this sphere and it's pulling in the energy. And I always say this, we judge our Earth based on a linear form of understanding. We only see things on one plane. We're not curving that plane. We're not bending the plane back around on itself. So we have no idea what the true effect is when we put it into that shape. That's one of the misunderstandings of this whole world, is you cannot see it in the straight line form. And I'll tell you this, when we're building plasma and you put two things apart from each other, and as you pull them, you get a plasma field, right? Pull them too far, it goes away. Put them too close, you get sparks. What happens now if it's a sphere? I put a sphere in the center, and then on the outside is where my plate is in a spherical shape. What happens then? See, that's the problem with the way we're building things now. We don't understand the shapes that we're building, but we apply the rules of flat linear things to those shapes.
Yeah, well, that's where Victor came in huge the other day, because it's higher dimensionality. That's the bottom line. You got to bear in mind that, like, depending on the wave frequency you're running, I mean, wave frequencies are technically three-dimensional in the sense that we're thinking of them, because you have your longitudinal wave, you have your transverse wave, so because of that parallel run, it creates a three-dimension. But when you run it along the surface of a wire, that's a two-dimensional trajectory. When you change the dimensionality of the wire by coiling it, it's still two-dimensional.
Yeah.
But your brain has a hard time realizing that, because you're looking at a three-dimensional object, that you've created when you're spiraling the wire. But
you only see it in the two dimensions.
But it is only two-dimensional because it is a wire. There is a point of input and a point of termination, which could be the same side. We know that, right? Depending on how you're building and what you're doing. But at the end of the day, it's still that. And just because you turned it around in on itself doesn't forgive the fact that it's still one run.
Yeah. That's what I mean. We don't build in three dimensions. We build in two. And then we see hieroglyphs in two dimensions when they're supposed to be seen in three. And your perspective changes once you do. See, we're only getting part of the information from those hieroglyphs. That's the problem. When you write things, they're in 2 dimensions, but they're actually meant to be in 3. Sometimes they're meant to be in a 4th dimension. Yeah. So you really have to understand things a little bit different. And if you're so set on where you are on something, you'll never understand the problem. You'll only go around it, and we'll never get further to where we need to go. You're just inside that little box, and you know what I mean? You're just stuck. You can't get out. That's why I always say, first you got to start thinking outside the box. Then once you start thinking outside the box, then you could throw it away.
See, I think that my love of science and my desire to see science transcend the barriers that it currently has, or that we think that it has, or whatever, and be able to enter into that science fiction realm of technology and ability. Like, I want to see that happen, but the more, and it's like I have I've shared before too on my solution to the problem that I'm already going to express, but because I'm admittedly right, even in this moment, subjecting myself to like the confines of sensory reality, as we know it, within some kind of rule box, and I admit it, but here's where a little bit of a problem in my own equation breaks down a little bit. And I try to forgive it the same way as the scientists do when they just try to rationalize something without fully understanding necessarily how you would do it, So it's sort of that situation. But where I'm going with this is, if you want to leave the locality of, and I'm not talking about Earth necessarily, but if you want to leave the greater locality, okay, of the solar system or the universe, okay, or whatever have you, and you want to travel at the speeds, again, time manipulation, we've talked about all this stuff. My issue is that there does come a point in time where the processes that are required to do these things, because of what I just shared before about the differential of energy to mass, that ratio, okay, and that equilibrium that kind of has to exist for stability to occur, okay, there comes a point in time where matter can no longer sustain moving up that chart. We talked about what I believe happens if you have a dual scalar field interaction. I think that it leads to dematerialization. And I think that it was decently well established as to how I reached that conclusion, it is what it is. So you really can't, and that's where Planck's distance lies. And if you can't break over that Planck's distance, then you really do end up in a box. Now, go a little woo for you. I think energetically you could do it. I think, I said, human beings, we are matter and we are energy. We are spirit, and, I do believe that, the mind and the energy, the spirit, I think that you can break that Planck's distance, alive, dead, whatever, okay, to be able to transcend to that level that it would take to super leave the locality, to super beat the speeds. You can, but your matter doesn't go with you. If it did, your matter would cease to exist, and that's where it gets dicey. I think that's where Einstein's stuff fell apart too. It was like right at that same kind of point. Like you could push it, but you could, as far as matter is concerned, you can only push it so far, because there's always a ratio. And that ratio, if it becomes overwhelmed by the energy it's surrounded by, will cease to exist. That's that. So
go ahead.
Yeah. So, I mean, if the only postulation that I came up with was right where the graviflyer is, and, two, and that was in my own independent thought, separate of it, because I wasn't even thinking about the graviflyer. It's just about, matter and space and context. And I guess the only way to do that would be to then create your own locality, like we've said previously. And how do you do it? Well, you need to mimic the same thing that's going on outside of this earth that keeps earth where it is, that keeps earth going around, that keeps it stable, that keeps it locked. It's locked to the sun. Just like you want the graviflyer in this case to be locked in the atmosphere and controllable, but locked. Why is it locked? Because of its locality. So you need to be able to have the interaction between the plasma and the magnetic field pressurized in order to then, this is where it fell apart a little bit for me because we've talked about it before, but it's to do with the density, and keeping it off the surface. The keeping it off the surface is super, it's so much more critical than I initially thought, because see, when I originally thought about it, it was, you got to keep it off the surface. Okay, because you need something for the craft to exist within a bubble to be able to push off of. And yes, that's the case. Okay. But why else does it need to be off the surface? Because if you've created a field that's separated, that's strong enough to separate you from your local density locality of atmosphere, okay, that means that you're having ionizing radiation coming off of it. It has to, no way around it. That also means that you have, if that plasma at that type of power level were to actually interact with the material of the surface, like directly, could be dealing with vaporization events, like right then and there. No different than a plasma, no different than a plasma cutter at that point.
But the thing is you have to have it on the ground to build the energy of the ether inside of it to be strong enough to allow it to sustain it within itself.
Self-sustaining. Yep, we definitely crossed that bridge. That was we definitely crossed that bridge as far as the experiments and as far as like the discussion
but
went.
If you don't have it on the ground, it doesn't produce enough energy to get self-sustaining because we're using the wrong energy to put into it from the beginning.
Right.
So let me just say something that kind of came to mind when you're talking about Einstein. You ever thought that people look at things a lot different and are seeing energy in a different way? So when I say energy, some people say, okay, that means AC or DC, and that's what you're putting into your system. But it's not what I mean at all.
Oh, yes. Yes. By the way, the answer is yes, but continue.
So when I say energy, it could be any type of energy. It could be, sun's rays, solar. It could be anything that the earth produces. It's just energy. That's all it is to me. So when Einstein looks at it, he goes, okay, I'm looking at the atomic level now. Now I have energy in the atoms, splitting the atom, forcing them together, things like that, right? So the problem with translating something that he's on in his level versus where most people's level is that we're on the level of AC and DC and we can't see outside the box. He's on the level of atomics where he can see outside the box and look back in and then figure out a way to build those systems without the original energy that you use. See, you get what I'm saying? Right. Then there's another level to that. Once you understand that level, now you can start transmutating things. Now it comes into, is this rock really a rock? Or is it simply the buildup of atoms in one locality? That's it.
That is it. Oh, 100%.
Those are the levels you have to go to.
And what you said, that was dead on. Like, I've been on, was my 4th, 5th time on with you. Talked about energy and matter and the physics of it all. And I don't know that I've mentioned voltage or wattage one time.
Nope.
Because, it's not that it's not relevant. It's only that it's relevant in the context of powering on your television. I mean, and not that that's insignificant or unimportant. It's significant, it's important, but it also comes from somewhere. Right. And before it's anything, it's something. And that's, who cares what it is when it's running down the line? Yeah. Like, I hate to say it, who cares what it is when it's running down the line? It's what it is when it's generated, and the force that the forces at work that create the generation of it, that ultimately matter in when you're looking to remove yourself from the locality. Tesla didn't say that it's voltage, wattage, and amps. Like he didn't even say that it's resistance, although that's a major thing. Well, but he did say that it is, energy, vibration, and frequency, because that is the manifest, that is the simplest form of manifest energy, and also the longest lasting, most durable form of electricity. A form of energy. It doesn't have propagation losses like AC/DC electricity. Even in atmosphere where it's subject to severe interference and atmospheric restriction, it still propagates without loss or bolstering. So exponentially more than AC/DC running through a line, that why you would think about AC/DC running through a line is preposterous to me. But that's to me, and I'm not talking down to anybody that's thinking in those terms. But if you're hearing the tone that I'm taking with it, like, let that spark something. That's all. So in between, the spaces in between, okay, I think that's an interesting thing. All right, because if we're following my same logic from the get-go, because we did get a little sidebar, not very surprisingly, and that's cool. But we have all these planets, we got all this interaction going on. Then you have these spaces in between, and it's electric universe. Now, there is an electric universe theory. There's a guy that came up with it, and it's a super interesting theory. And it's not that I disagree with it, okay? I don't disagree with it, but I think that either in his paper that I personally read and some of the material that I consumed, like on YouTube and stuff about the topic, it was very implicative of what you just said. So it's an awesome segue. It was very like thinking about energy as electricity. And I think that's the point that I disagreed with. Yeah, it's an electric universe, because everything being, electricity being a byproduct and result of the higher orders of energy. When you're dealing with energy density and you think about it as mass accumulation, and then you think about it as energy working against that mass accumulation, and then that you have these mass clusters and that most of it in between's empty. Well, it's not that it's empty. It's the same thing we've been talking about all along, which is just pure potential. It's the spots on that gray page that it was gray, but then other spots turned black, so then other spots were white, and then there's pieces of the page that are then white. So certain spots on the little blank white page, after these processes rolled out, we didn't kind of get back around to that because we got a little off on it. But when it starts to do its whole clumping together situation with the mass and with the energy, and then the energy is creating mass and it's equalizing, and everything reaches some form of stability, there are parts of the originally white page that are white again. Okay, but remember something: all it ever took for the white to become from potential to probable, usable, okay, was the presence of anything other than its perfect little effing self.
Yeah.
Okay. Its perfect little still self. All right. The instant anything else came in to disturb that perfect still, it all unfolds again. Now, to what degree? And how overwhelmed is it? Well, here's the thing about mass that's crazy. If we look back at what I originally said, it's condensed energy to the point where it's solid. It's condensed energy. In fact, we know this. You ever light something on fire before? You know, you have an ambient temperature working against it of, it's 75 degrees out. I just lit this log on fire. It's 500 degrees at the log. The log has more energy than its ambient energy that's being exposed to it, which is why it exists as a solid. That's the point I've been trying to kind of get to. I think that's probably the best analogy to describe that. Now, if you're talking about any solid object going through undisturbed potential space, that solid mass is going to have a higher, a much higher density, so to speak, than its surrounding area. So I don't think it would be acted upon in a way, and again, this is postulation, but I don't think it would be acted upon in a way that would overwhelm it. It would, however, initiate the electrodynamic process. We'll call it that, the electrodynamic process in that area because the mass is there. Now, here's where things get really whacked out, okay? Remember how I was talking before about mass-like energy and energy-like mass? Here's a great example of that we could all understand and relate to, all right? You have a piece of plutonium, okay? Hey, nice chunk of plutonium. How are you? Well, I'm fine. I'm throwing off all sorts of gamma radiation. Oh, okay. You're very energy-like, aren't you? Yeah, gonna be for a while, See me after my half-life. All right. It's unstable, so it's throwing off its energy that it's made of. First of all, that's a scientific simplification when they're like, oh, it's a radioactive substance. Well, what does that mean? Well, it just means that it has radiation. Oh, okay, for most people, that's fine. Yep. This piece of matter is so energetic and then so unstable in its energetic composition that it is throwing the energy off by itself. Let it sink in for a second. It's crazy, and it fits right into everything that I'm saying with this, okay? Now, what happens when all this energy coming off, and then you put some more, and now you got even more energy coming off, and the energy coming off overwhelms the amount of mass that it's within. You have the matter, then you have it expelling energy, and when you reach that certain point, the energy in that area overwhelms the mass it's working against, and it fizzes. Well, more like. Then what happens? Everything that's in the blast radius vaporizes.
Yeah.
Everything vaporizes. They don't say, oh, it all got burnt to a crisp. Oh, no. It vaporizes. The energy is so ready to go out of that matter that when it reaches critical mass, it goes. It goes and it overloads the entire system of that particular area and takes all of the matter with it right back to the heaven where it came from. That's it, right? Now you talk about fission, and fission's even crazier. I mean, fusion. You talk about fusion. Fusion's even crazier. This is where the most interesting thing I think about this whole part of the discussion is the gas giants. without going into how I think they came to be, although I got my theories, think about the nastiest. Okay, you know what? Let's go there because I'll make it brief. Think about like a mass, okay, that's not even that big, okay, but it's very energy dense. And it's got tons being a descriptive word, of energy working against it, okay? And it's being overwhelmed, okay, but it's got so much energy density itself that it just keeps on breaking its matter down because it's so overwhelmed by energy. Okay, and all of this matter that's within that, it's all being broken down into hydrogen. Okay, it's rapidly expanding with hydrogen so fast that the energy working against it, it can't even do anything to, it's pressurizing it, basically. Okay, so you have an expansive and a pushing force. It's this nasty battle line. Okay, it just keeps on happening, but the energy just keeps on going because, frankly, it just doesn't have the ability to stop it. It basically burns any matter into a crisp, and then anything that could possibly be freed into a hydrogen atom was. Okay, and then after the core was depleted, now you were just left with this big gaseous ball of hydrogen and hydrogen derivative. What's hydrogen derivative? That's also subject of, it's also a secondary of decomposition to further prove my point. Ammonia and methane. Okay. Jupiter and Saturn are hydrogen, ammonia, and methane. That leaves most likely, in the comments, please, if you want to pop in there. I don't know how many people we have.
20.
Nice. My 20 favorite people on the planet right now, 21 including Nathan. I think that all that's left at the end of that type of reaction that results in that massive amount of hydrogen distribution is got to be carbon and silica. That's pretty much about it. Okay. What happens when you have a planet the size of Jupiter with a depleted carbon silica core? I postulated myself that I think that they have diamond cores. And ironically, although you can't say it about Jupiter, though it's got a spot that it's a storm, okay. I'm not saying it's not, but it's an anomaly on the surface, all right? If you look at Saturn, it's got a hexagonal top. Well, diamonds form cubically. So if you look at a square, a cube, you look at it from its obverse, from the corner. It's the cube. That is the cube of Saturn. Well, and it makes sense as to why it's all hydrogen.
It does make sense. What I think is it can't form crust around its inner layers anymore. The planet just can't do it. So if you put a crust on the outside of the core, and then it can have something to pull the gravity into, then the process can start working again where it starts filtering through its core. But it can't do it because there's no crust on there to give it enough pressure to create that pressure zone. So it's no longer in that process. It's now all expanded way too far out. It can't come back in and form water, clouds, things like that.
Okay. What you're saying, again, it's my opinion. It's only for the purpose of this conversation. I'm not correcting you. Okay.
No, go ahead.
What you're saying, it kind of makes sense. Okay. But here's the one thing about the hydrogen. It's liquid. And it's all how you define crust. What's crust? Is it crust solid matter because it's solid matter on Earth? I mean, we could call it an ocean because it's liquid. But think about the immense pressure that you have to put a single electron and a single atom under to create a liquid. We could do it on Earth under immense pressure and condensation. It doesn't last because of our atmospheric pressure differential, right? It immediately evaporates, entropy takes place. It's super cold. But I mean, my understanding is that what's crazy about that ocean, okay, is that it's under so much pressure that it actually breaks the free electrons from the hydrogen frequently, resulting in an electrical discharge from it. Okay, and that gets returned back out to the system. System presses. It's in a state of equilibrium. That's why it has its current orbit. That's why it's been on that trajectory for however long. It's reached a state of equilibrium with a hydrogen sea. But I want you to visualize a situation where the external conditions of the planet, okay, not the planet's conditions, the external conditions of the planet change. Okay. If the energy working upon it, okay, were to dissipate, okay, that would lead to rapid expansion, even further rapid expansion, because all that pressurized hydrogen, it's going to want to expand.
Right, but that's what I'm saying. They can't create a field like we do around our Earth. Mm-hmm. They can no longer create it, so the rapid expansion happened and it turned into a gas giant.
Well, but they have a stronger magnetic field than Earth does by magnitudes of orders of magnitude.
Well, I understand that, but what I'm saying is because they have no pressure on the inside of their planet, they don't have that field. So it expands out. Therefore, the inside cannot be contained by the outside. So it'll start pulling in everything from everywhere. You see what I mean? It has a bigger field because it cannot sustain itself within its field. So the outside impact is much, much more than it would be. So if you were just to take a Dyson sphere and put it over Jupiter, it would completely change it. As a matter of fact, it wouldn't crush it because the inside was so great a pressure, it would equalize it and balance it because of it. Because it has to have that field around it in order to sustain itself to keep the processes going. Once you break that field, it no longer has the ability to change and make those transmutations happen. It is now one big field of garbage sitting out there instead of a constantly changing field.
See, I look at it a little bit differently. And maybe we're talking about two slightly different things, and that's possible too. And if it is, it's very nuanced, but it makes all the difference, I think. See, if there was a change of the amount of energy, let's forget about the magnetic field for a second. Let's just call it a change of the amount of energy exerted on the planet, whether it be more or less. Okay. There's going to come a point in time of compression or, of compression, or I guess contraction being the opposite. But I mean, expansion, right? That it's going to end up reaching critical mass. There's such a thing as critical mass of that particular system as there's any particular system. So depending if critical mass is reached during an excess energy event where it's then compressed further and further, okay, that compression would lead to fusion. What happens when you start to fuse hydrogen? You end up with a star.
Yeah. I don't think it's going to make it into a star, though.
Well, so the opposite happens if it then expands. If it expands, then it explodes. So it lights fire.
But when we're talking about the fields that come out from the sun, right? And where Jupiter is in relation to it versus the asteroid belt. So if it cannot sustain itself to that field, it explodes. like whatever was in the way of the asteroid belt, if it truly was a planet based on cuneiform writing. Okay. Now, if Jupiter made it through, but then it lost its atmosphere going through it because of the energy, you put too much energy into it, then that's the state it's in now.
Yeah.
Do you get what I'm saying? That's why I keep saying that the outside of it expands, but it has more energy in it than it should. It shouldn't have that much energy. There's something pressing upon it to give it that energy. That field where it's cutting off is hitting right there, right in between, the asteroid field and Jupiter, and it's causing Jupiter to expand the energy out of it. It can't self-sustain itself anymore. It can't create the atmosphere around it that it needs.
Yeah. No, I get what you're saying now. And that does make sense. Absolutely. I mean, in my opinion, stars are pretty stable things because it's like a controlled, not controlled, but you know what I mean? It's there's a pattern.
Yeah, no, I agree with that.
Right. There's a pattern to its processes, to the point where, you can calculate its potential lifespan and know its different cycles and know probably within a 10,000 year range or whatever when it might start to drift into another cycle. Like, I mean, obviously we're talking about very long periods of time and stuff, but the fact is that it's it's not like a candle where you blow the sun out. There's once that process is undergoing and it's short of the most catastrophic types of celestial events that could possibly happen, it's going to do that. What's crazy is the instability of the gas giants when you realize they're just hydrogen balls surrounded by potential electric fields. Well,
there's got to be a core in there somewhere. I mean,
look, if you want to be scared about something, if Jupiter or Saturn ever pop off, you're going to know about it.
Well, that's the crazy thing about the universe, isn't it? We apply the rules on Earth to the actual different planets, right? When we shouldn't. Because if you go over there and it's all hydrogen, you're thinking light a match, it's done, right? But then you see asteroids coming into it. All of a sudden you see these big fireballs and you're wondering, well, why didn't it go off?
Pressure.
You know what I mean? But
lack
that's what
of
I'm
oxygen.
saying.
Pressure, lack of oxygen, that so many different reasons. But
we're applying the rules of Earth into
absolutely,
the rules
well, we're right because its equilibrium is different than ours. We're both in states of equilibrium, but theirs is vastly different than ours. We're at the point where we could say it's terrible all we want and be like, man, for all my Canadian folks out there, and there's so many of you, man, it's cold. Where's my hat, eh? Like or whatever, or or it's hotter than hell, in Brazil. Okay, fine. And then climate change and all this stuff. Like at the end of the day, anytime we're ever talking about these things and it's significant in effect on Earth, we're talking about 5 degrees here, 10 degrees there, or something like that. It doesn't really take much to throw off that level of equilibrium to the point where there's a 5-degree temperature shift due to all sorts of, potential events. So we're fragile because of the state of our contentment in our equilibrium, that on the other hand, it's not suitable to us, but it is to an equilibrium, and that one's a little harder to disturb because it just hasn't undergone the celestial processes that we've undergone chemically. If we follow what I originally said about it being degraded, I don't know what the oxygen content is. You really can't have ignition without oxygen. So that's sort of what it is. What's up, Joey? I see you in the chat. Very good.
Yeah, by the way, I'm sorry. I was so into the conversation that I didn't put up the chat because I wasn't trying to break my train of thought between you and I.
Yeah. No,
sorry about that.
Yeah. So I think that the the answer really is that the gray, like we were originally discussing, that gray is, the potential that we're all after. That's the ether, and it is the undisturbed, unmanifest, that we can all tap into, and that's what's in between. But you got to remember that once you expose that to matter in context of what we're discussing, it does change the dynamics and the properties. And it's always just something to bear in mind. It's one more variable. And because I don't experiment and I only play simulation games in my head, like that's the only reason it's coming out of my mouth. I haven't observed anything to really know what the effect of something like that would be. But
well, I wanted to bring up something because we talked about it a little bit earlier and kind of go off on it a little bit. We were talking about that Tesla coil, right? And I think it's funny we're talking about the geometries of things and how they affect them. So in a Tesla coil, everybody thinks, okay, let me put in, like 30 volts, and then I got to have at least 10 amps, right? Well, is it really 10 amps? You know what I mean? Is it really that high? Do we need that, or do we think we need it? So I say that to say it in this way. If all you're trying to do is create a resonance that resonates another coil, the amps are what's causing the breakout. So you have to reduce those. They come out in voltage because the Tesla coil itself translates the amps into voltage is what's going on. So people, if you don't understand how volts and amps work and they translate to each other, that's going to be a big problem for when you get to the end of it. So I only say it in this way. When you're talking about a planet and the sun, there's a relationship there. It doesn't have to be a mass amount of energy going in. It has to be resonating. That's the thing. That's all it has to do. That's where your energy is built. It's not built in the energy that comes in. That's just a starter for it. That sun is absolutely over unity. Therefore, it's taking resonance to create it. Therefore, each planet resonates. So as we reach each part of the resonation in the planet, it changes how much energy we get. So we may be getting one resonance, while Mars gets another resonance, while Venus gets another, and we're all different in that way.
Without a doubt. And even on Earth, the differential of resonance, we're all pretty much, on the planet and somewhat, hopefully, in tune with like Schumann's frequency. But at the end of the day, there's great variation among mass on the planet that deviates from their resonance due to our locality. That's where my end of things go. Like in the inner self, you raise the vibrations, you come out of the confines of where you're at. Okay. So in turn with that, it all is resonance, because what's interesting is when you have a system in resonance, that's where you get free flow. Okay, that's where the free flow comes in. Now, if you remember about the idea for the over unity device, so to speak, that I discussed, just the theoretical, the key to it was that the frequency running through the coil wire, okay, was it has to be in tune with the quartz that it's going into. Okay, we know that the quartz runs at 32,000 megahertz or something like that. It's pretty high, but it could be derivative of 32,000. If you run it through that, when it spikes and you close the loop, okay, realistically, the output should match the frequency that was originally going in. And because it had that spike that was greater than the original input, it would then run the system, provided that your your coils are short. Okay, they have to, the whole system's got to be pretty tight. Okay, and that the coils that you're running, maximize the interference, but almost as close to eliminate as possible the impedance. Okay, and the way that you overcome that impedance issue is by asserting the load, because the height of the spike in the system, as far as I can kind of postulate, if you're running it through the system, if it kicks on as it pulls, it should increase the amplitude of that particular spike. So it would be enough to power it at the higher amount, so that when you then add additional load, it's just pulling more, just like we talked about. It's funny. I don't bank on ChatGPT. Okay, I don't really like that, but I do have fun with it. I like to ask it questions. I put that device into words, described it, frequency generator, doing this, amplifier, leads, this gauge wire, twisted, put in this way, directed this way, a flyback with a breaker that closes it when the spike comes through, okay, and rerouted opposite one another. All right, ran it through. It was like, well, this would be interesting. You could expect many phenomena. I was like, like what? And then it was like, then it was telling me that it would give over unity, but then it was like, but over unity doesn't exist because it breaks entropy. I was like, suppose that, it's not creating energy. Suppose it's just being able to pull the energy in from around it in this scenario. And they're like, well, that doesn't break any laws, and that ought to work. I was like, well, thank you. I was like, I don't know that it's going to work. And honestly, ChatGPT, and it hallucinates worse than I do when I'm sleeping.
Yeah. One of the things I'll just tell you about Tesla coils is kind of a thing that Tesla knew, and this is why he built Wardenclyffe the way he did. There's a rod right down the center of it that's not attached to any wire. Okay, what that rod does is it pulls energy from it. And where that rod stuffed is right down into the water. So he's pulling energy into the earth and making the surrounding earth itself energized. So when you talk about a double grounding, right? So you have a Tesla coil that's grounded in that fashion. Now, anywhere I go, I could put the light bulb into the earth and light it up. And that's like the second ground. You put the ground in there and it pulls the energy out. That's what he was doing, and not a lot of people understand it. Now, that's one of the key features of learning the Tesla coil. It's not just that it creates sparks. No. You want no sparks. You want it to resonate, and you want to pull the energy from the center before it's used. That's cold energy. That's what you want to put into the ground. That's what you want to put up into anything else that you want it to go into to amplify the amount of energy in it, is have it right there on the ground. So it's building the field. Now it has time to pull it in. Now it has all the ability to do it. That's the only way to create that. Yeah. That's why the wire's down my Tesla coil the way it is. And if I go in reverse and put it into my ground, guess what? I've now created the circuit that goes to the ground. But now anything excess in that ground, like the water created, that the magma created, anything like that, I can still now start to pull from that. I can now start to pull that ether, the energy that I actually wanted, is the one I'm going to pull. I'm not pulling the energy that man made, the AC, the DC. Those are just means to an end. That's not the energy I want. I want the energy from the earth, because I need to equalize the field of the earth to make it so that it can push against it. You know what I mean?
It's the pressure differential. And this is why, absolutely, first of all, you're a brilliant mind, Nathan, and Gerald's a brilliant mind, and Sean's a brilliant mind, and the whole rest of the guys. I'm not going to name every single person. You're all brilliant minds. All right. The case in point that, that's why I love talking to you. Every time we talk, it's the different flavor and application of the same exact things that always boil down to the same exact things.
Oh, they do.
The frequency, the resonance, the pressure differential. The whole entire point of me wanting to come on here today was to tell you about how the universe was created in my most abstract way possible that was clear in my head. But as usual in delivery, probably not so much. That's why, guess what? that's why when they wrote all these books throughout the millennia, they used allegory, they used metaphors and things like that. A, to keep it a little bit hidden, but B, to also make it understandable, because I could see it all in my head. Getting it out of my mouth is a whole other subject matter, in an effective way. And I think that this was early realized. But hey, if you wouldn't mind, would you mind throwing on that song that I wrote? Because I think that it really paired well with the episode. Yeah. I wanted to put that out into the ether,
It's not a problem, Joe. Just give me a second. It takes me a few seconds to click around.
Thanks, Nathan. I appreciate it.
Yeah. I'm almost there.
For anybody that's wondering, I'll never stop writing dumb songs. I've been doing it my entire life, but now that I had to sell my bass and stuff, a few years back, so I've been playing, and I don't really get out like I used to. So the AI music generators and stuff have really been the friend to me, where I could still engage in writing music and stuff, and have it actually be something more than just words on paper,
Okay, let me ask you. This is the one you sent me right here, right? Fire the Spark version 2?
Fire the Spark. So yeah, this is a little double entendre, triple entendre type of lyrics, Hopefully, can you blow it up so we can see it?
I'm going to as much as I can. Okay. Just give me a second. I was waiting for you to be done talking so I could
I'm done. Please, I'll never stop. You know that. Fire the Spark, Nathan.
That's as loud as that.
Definitely on Bandcamp. No, it's on here. I'll give you a call. We'll talk about it. That's cool, Joe. Go. I'll tell you what, man. If you were working out right now, it'd be really awesome. You know what I mean? Because the background, the music just totally punched it. Yeah. I think that this the AI did pretty good. It hallucinated one time and just said a couple of words, but I forgave it because I was like, you know what? This is a really good composition for what it's worth, Yeah. You can stop it. It's more or less over. It's just going to say more of the same crap. Yeah, but that was the whole idea of the song was, I'm sure you were following along anyway, but, a perfect still. It's complete. It's disturbed. it becomes cracked. There's a void. You know, it doesn't know what to do, but it needs to return to its, you know, previous self. It's got to heal and mend that crack. So it starts throwing itself in there to fill it, only to realize that the more that it throws into the void, the more that it just falls apart somewhere else, you know, until it kind of reaches the bottom where it's full. And then at that point, the pressure mounts and it's destroyed, but it's not destroyed in the sense that it's gone. It's destroyed as, you know, a transmutated change to then ascend and fire the spark. So, yeah, that's on my YouTube channel. My YouTube channel I'm working on with a friend of mine, Brandon, who's on this. I'm unfortunately probably moving in the next couple of weeks, so I'm probably waiting until after I move to start production on that, because it just seems a lot to start putting together some video content, put it out there, and then you know, I want to be able to keep the momentum of keeping the stuff coming without that break. So
nice. Are you going to put a lot of music on there? Or are you going to do what we do here, a little bit of theory stuff? What are you going to do?
Yeah, so my format's going to be kind of interesting. Yeah, because it's me. It's going to be an edited format. It's you know, scripted, edited, not fully scripted, but like there'll be segments that are a little scripted, and voiceover, that sort of thing. But I want to do segments, and one of the segments that I want to do within it is just kind of talking to in conversation and interviewing like different people doing sort of interesting and fringe things.
Yeah.
You know, just to kind of ask them what they're all about, how they got into it, you know, where they're at, where they see themselves, what they've done with it, that sort of thing, and have them present whatever it is. And, you know, I definitely want to have you on there. And then, you know, a guy that I watch all the time, he was in the chat. I saw him, Joey, Library of the Untold. Amazing channel. That's a shameless plug, because honestly, he brings so much, like incredible content. You know, just really, really incredible content. You know, frankly, between me and you,
right here,
I absolutely aspire to have that production quality. So yeah.
This is the guy right here?
That's the guy right there, man. I'm okay. Telling you, like, big fan. Check out his channel. That's a shameless plug, because really he's given back so much to you know, the esoteric and the cult community. You know, and really, frankly, you know, he's formed one of his own, you know, and it's a great group of people over there too. Yeah, so you know, it's something I inspired to do, but I want to have him on too, and I kind of contacted him about that.
Okay.
So that's one part, and then another part I want to do, just because I'm a total dickbag, is I want to take like a cardboard box and make like a puppet thing out of the cardboard box. And then what I want to do is, like, I want to have the cheesiest like sets, like literally drawn with like crayons and sort of stuff, you know, like set up in this puppet box. Yeah. And I just want to like write scripts, like humorous scripts of like different things, like, and it'll be the most random stuff. But one thing that like comes to mind is like the Pistis Sophia and the Gnostic creation. Like, that's one thing that I'm like, yo, episode 1, that's going on, because, like, you know, try to watch my mouth as much as I can, but it's going to be like a moral oral type of format. So it's going to be like this cheesy, terrible thing. It's going to be like God, but he's on a popsicle stick. Look at crayon drawing of God on a popsicle stick.
Some imagination there, Joe.
A crayon, you know, drawing of like Jesus on a popsicle stick, and then like Sophia, and then she like thinks the demiurge into existence and stuff. God's like, Sophia, like shaking, like, and he's like, Jesus effing Christ, and then Christ pops in, and he's like, yeah, Dad. He's like, no, not now. You got a few more. You know, like that sort of crap.
Wow.
It's like, I don't know. That's my sense of humor. You know, I keep it very PG-13-ish as much as I can for your show. Probably PG, but you know, like my personality is just like.
Well, I can start to see it the more we talk.
Yeah, you know, and like the Joe you get like a backyard barbecue is like, you know, it's hard to be that same person when I'm talking about frigging physics.
No, I get it.
You know,
I get it.
You're getting deep thought patterns and stuff, and you're like, oh man, and like I'm always just thinking on the fly. Like half the stuff that I even say on these shows, like I have like the idea in my head, and I don't think about it until I come on, and then the more that it evolves, like what's coming out of my mouth is evolving as I'm saying it. Like, you know, that's why I put a disclaimer at the beginning of the video. I'm like, listen, I'm gonna say some whacked out stuff, and take it all with a grain of salt and see where you fall with it, because, you know, at the end of the day, I don't claim to be right. I'm just trying to inspire people to, you know, have that creative mindset, you know, to make them better understand the concept. So that's sort of where that's at.
Yeah, we'll have to do something, you know, with the live with this music, as long as everything is not, you know, out there where it gets us in trouble. You know what I mean?
None of the stuff I really write is, you know.
Well, you're on the show and it's your music. So just so everybody knows, that's the only reason I play it. Because if it wasn't, I couldn't play Joe's on my channel. They'll still ding me. You know what I mean?
You have my permission.
Yeah.
It would be overcome.
Yeah, that's what I'm saying. You're on the show. So yeah. Trust me, I'd play all kinds of music if I could.
Yeah.
They get really bad about that.
Well, actually, the app that I use to make that, for what it's worth, they have royalty-free music that you could just like generate and have playing in the background, just to, even if you, whatever vibe you look for in this, you know, you could just type in like, you know, background music, this type of, you know, general genre, no lyrics, whatever. And it'll produce it, and then you can just have it running in the background. It's royalty-free, you know. Yeah. It only becomes yours, I think. I read their terms of service because I was dumping my lyrics into it. And I was like, you know, I don't think it's that good that anybody would like take it and try to make money with it. But like at the end of the day, like if somebody did, I'd probably like be like, come on.
Yeah.
You know, like, can't I catch a break? How come you made a buck off of me and I can't make a buck myself? Like, please.
Well,
you know, but
anyway, the app I'll show you real quick. Let me just put this back up here. It's right on the bottom. Sunyo, SUNO is the name of it, and it's on his lyrics here. So, just so you guys know, that was they were asking in the chat.
Yeah, for sure. That's highly recommended, because if it's nothing else, it's fun. And if there's one thing that I can give AI credit for, you know, as someone who likes to, you know, paint and, you know, write lyrics and write songs and stuff like that, is, you know, like there would be points in my life where like I had reached such like a creative block, and I think that anybody that's creative has, you know, and that will snap you out of it. Like, you know, sometimes you write like lyrics and you're like, but I don't know how the song would go. Like I'm trying to gather that in my head. Well, this, you could generate like several different ideas, and none of it's going to be perfect, but like you'd be like, okay, well, I see where this is going now. I could build off of that. So even if, you know, you're just using it as a tool for inspiration, that's cool. And as an artist, you know, like there's been several times where I was like, you know, have this idea in my head, but like every time I'm putting it on paper, the composition just like isn't really where I want it to be. So, you know, I start playing around with just the generator to see kind of how it's creating it. And I'm like, oh, okay, cool. Now I see the way that it's forming it, and I like that. Let me go with that. It's no different than walking through an art gallery at that point, looking for like inspiration there, or turning on the radio and looking for inspiration there, but it's more custom to whatever you're trying to do. So I think that's cool, you know.
Well, I think the whole thing's cool is that the fact that they, without you have to get out all your instruments, they put a little bit of music behind it. Then you can see if you like that kind of tone that it's going with. And then if you do play those instruments, then you get to rock out, you know what I mean? Push it to a different level on there, you know what I mean? Or just change it altogether. So for me, that's cool.
Yeah, but listen, I don't want to go on and fluff the guy up too much, but Joey, I know you're there, and I want to say this because, like, honestly, I've been watching you for so long, and I've never really had the chance to like say anything to you. So I guess this is the opportunity. I'm not fluffing you up too much, but what he does, I want to tell everybody here because I think it's so impressive. Okay, is that first of all, he does all his own research. He writes his own scripts. That's cool. But when he's done producing the video, he actually goes back, watches the video production with the voiceover, and then he audibly narrates his own soundtrack on a synth.
Really?
And does a custom to every single video, so none of it's the same. So he sits there and watches the video back and then plays over it, recording it, and then layers it. And I mean, the amount of talent is just incredible. That's what I'm saying. Like, I mean, it's absolutely next level incredible, for one person to be doing all that. But yeah, that's like something else. Yeah, right. I told flush your cheeks, buddy, because I told you I'm not fluffing you up too much. I'm just like, I'm really, it's on subject. We're talking about music and videos, and frankly, I'm, when you told us months ago that you did that, I was like, really? Oh my God. I was always wondering where it came from. And I was like, I can't believe it's this guy creating this, but yeah.
Yeah, give me a second. I'll see if I can't pull the link for his show.
All right. You get a little free plug.
Let's see right here. I'll hit subscribe on there, and then we'll.
Now, look, I'm trying to drag people down the rabbit hole with me that I've already been down for years. But if anybody's looking to get their feet wet and really deeper understanding scientific concepts, go take a look at this guy's channel, and pretend like it's stories at first until you start believing it, and then you realize,
Oh, here we go. Share channel. There we go. And I'll put it right here. And there you go, guys. Right on. Sorry, it took me a minute. I always worry about that because my eyes keep looking around because where my TV is and I'm trying to pull files. So
yeah. So yeah, I mean, that's about it. How's things doing in your workshop? What are you up to this week?
Well, just working on my coils and stuff, trying to catch up to Ben. And once I do, then him and I can start collaborating on, what experiments he does and things like that. And being that, I have a few more tools than he does. We'll be able to push it a little further. I'll do it, and then he'll be able to replicate it, or vice versa. You know what I mean? Cool. And it'll be a true collaboration to get to the top of where it actually is. And it'll give me good because it's the same circuits that Gerald's running in his that are going to be applicable to this. So, you know what I mean? I can run them through flat coils. I can run them through the big rod and coils. I can run them through other ones. And then I could test out the geometry of the coils like Gerald. Then I'm finally getting somewhere. You know what I mean? And we can actually, when we break it down, we'll have a bunch of notes on exactly what they were, the frequencies, things like that. And you'll be able to see it on the oscilloscope as well. So then it'll just translate a lot better for anyone out there. You know what I mean? When we put it out.
Yeah.
Some of this stuff's kind of dry when you put it out. It's like, oh, I got a coil. I didn't tell you much about what I'm doing with it, but then here you go. Here's a spinning ball. And you're like, hold on. If you told me the frequency of the amps and the, volts, and then you told me, what kind of sine wave it was or whatever it is, then I have a lot more understanding of it. And that's kind of what I want to pull out of Ben when we're on those streams, is I want those little nuggets of information that he has in his head that he hasn't given us yet. You know what I mean? As he's doing the experiment. So hopefully that'll help him.
Yeah, I know he reached a little bit of an impasse with his amp situation that he had going on, but that new amp looks like it's treating him well, and I'm so happy for him on that. It's got plenty of power. He'll be able to definitely grow a system with that. And looks like he's putting the proper protection in place now, to make sure he doesn't, send the spark back where it came from,
That's kind of the biggest thing there, isn't it? You just don't want to blow stuff up.
Oh man, when I saw that, when he said that he blew his friggin' last amp up, I was like, like I felt so bad for him because I was like, I knew exactly why in my head, and I was like, oh man, like, you just cost yourself a week of lab work, and
Well, the one thing is too is when you get a frequency generator and then you put it through a trigger circuit, it's a lot better. So the wave is clean. It doesn't have to go through any other circuitry. It's clean. Once it's released, it's done. And that's what Gerald uses in his. So that's why I kind of wanted to get Ben to go to his, his bench power supply with the trigger circuit, because then there's no frequency generator, then an amplifier, and then this. It's just you're going from one to the next. It's not necessarily always the volts and amps that go into it. It's that frequency.
Yeah. Because
you're trying to induce resonance into your coil.
You want to know what I have a curiosity of, and I've been thinking about doing it with my own little BS, scalar, propagator that I made. But since you're running audio, I really wonder what would happen if you run it stereo, like right and left stereo, and then you actually run known transcendence binaural beats through it. I wonder, because why not? Like what, why wouldn't you want to try and see what that does? There's a progression that some of the more known audio patterns do, to assuming that everybody's just at alpha state or right around there, which is mostly in resonance with the planet, and just that's sort of where that's at. There is a specific tone frequency that they progress through in resonance, with offset, because of the binaural beat pattern, with an offset middle frequency, that might be really, really interesting just to see what that type of progression in resonance, bringing it from around 7.345 all the way up to higher frequencies would be. You might get different effects at different levels, or it may stay the same.
Well, let me tell you something real quick that not a lot of people realize. When you put something in resonance, say it's at 300 kilohertz, right? Mm-hmm. Primary and your secondary and 300 kilohertz. What happens is the actual resonance frequency drops down to 200 and something. Mm-hmm. So it's the resonance between them that gives you the right frequency, not the resonance that you put into it.
Well, we know that. That's what we've been talking about, is constructive and deconstructive interference. The entire, that's been every other episode we ever talked about.
But they have to understand that when it's coming out of the earth, it didn't start in that frequency. So when you go to recreate it, you have to recreate it the way it was created. You have to go back and put a higher frequency in on both coils in order to get the correct frequency, like the earth says, because that's the resonance frequency. That's not just the frequency you put in. There's a difference there.
Right.
You get what I'm saying?
Didn't Sean show how to test for that the other day and actually identify what the resonant frequencies are?
Yeah, but I'm trying to make a point here is in the fact that everybody thinks that, hey, let me just take this frequency and run it, right? Let me go turn on my headset, put on 432 on the hertz, and then I got it, right? But that's not the way it works.
No, that's not the way it works.
You have to, one's at, probably like 500, and the other's at 500, and inside your brain it turns to 400 and something, right? That's the point. That's what I'm getting at. Not everybody's understanding that.
Well, you can up the octave of the frequency to then create resonance with an offset.
If they say it's 432 coming out of the earth, it's a resonance frequency. It's not a frequency, a regular frequency. Okay? Mm-hmm. It's two frequencies creating that frequency. There's a different level here. That's what I'm trying to get at. So you're not just putting in the frequency and you got it. It doesn't work that way. That's what I'm trying to explain. It's the same thing as seeing volts and amps in our AC and DC system instead of energy from the earth.
Well, right. But I mean, if you think about it, when you're using, just talking about AC and DC, when you're looking at three-phase AC, that's not matching the resonant frequency of the earth on the offsets. It's just simply not.
Well, that's what I'm saying. It matters how you build it.
Yeah.
People don't understand that. They think they just throw it in there and it's good, but they're not realizing what it is that they're doing. So
now that's why I'm interested in seeing if the same interactions with the same offsets that affect your state of mind and allow for energetic transcendence internally. I wonder if that manifests in any sort of way within a coil system.
Yes. I could tell you we can't talk about it, but I could tell you the answer is yes. That's about, I can't go into the medical side of things or else I'll tell you the full answer, but the answer is yes.
Yeah.
So, yeah. So I wish honestly we could, because it would make it so much simpler, but we can't.
Oh, I am in the law field. I'll have to take a look at YouTube's terms of service and.
Oh, they don't have it on there. Yeah. Well, I'm sorry. They don't have the medical side on there like they should, because they're not allowed, and that's the reason why you can't ever find it. But
I think that the way that people get around it, for what it's worth, I think you don't imply that it does anything specific. It's how you talk about it. If you say potential benefits, or you say, like for instance, if you have a yoga channel, you could talk about how it makes you, more flexible, or that it could alleviate back pain, because because that's the nature of yoga. If and those people are monetized. So I'm saying that there's like a fine line. You just can't say, if you want to.
There's a fine line when you have
that. I'm not going there.
When they don't bust you for it first, it's easy to cross that line a little bit and play with it. When they bust you for it and you got in trouble, it's a lot harder to even go near it.
Yeah, I understand. Yeah. So, well, we could keep that to separate conversations.
Yeah, but you know what? I like to talk about the universe conversation and the planets and stuff.
I love that stuff.
Lot easier. Some of the stuff in just the science stuff, it's a lot of working on things and a lot of figuring things out. And sometimes when you read it in the book, you don't get the full understanding of it. And they're only telling you the successful experiments. When all your experience comes from the negative ones that don't work, then you know why it didn't work and why the next thing will work. And it gives you a guide. And it's like trying to farm by a farming book instead of doing it yourself. It just doesn't work.
Right. No, it's true. There's only so much you can get off of a diagram. I mean, it's tough. We all have different minds, though, and it's like.
But there's difference.
My mind is such a busy place, but I can shut it down. That's the key, man. I don't know.
There's difference in what you do, Joe, versus what I do. So when you talk, you're talking about a whole different thing, right?
Whole different thing. And then there's no trial and error involved with what I do.
Right. So then when I talk, I bring it in the aspect of these experiments that I've done, and I can see it in the lab, and then we find a way to reach the end together.
Yeah, it's true. That's it, man. It is the symbiotic relationship. That's what it is.
You can't have one without the other. It's like I always say this, and Gerald always talks about mathematicians, and he doesn't like them at all.
I know he doesn't like them.
But when V. Sears came on, he loved it, right? And
that's a different approach to math. Yeah. Uh-huh.
Well, that's all it took. But see, you got to have both sides of it and an understanding between you two that you're on the same track. And then it starts to work together.
I don't know if Victor's in here or not, because I haven't looked at the chat, but
I haven't seen him yet today.
No. Well, if you catch this later, Victor, let me just tell you that was one of my favorite presentations I've ever seen. And I've watched it through the first time, but then I started watching it again because I have to. It's one of those things that you really have to watch a few times to get the figures, to make the sense, to be able to apply it. That's for me at least.
Yeah. So for those of you who weren't there, we were talking about fractal geometry, and Victor broke it down in every single way possible and made it relevant to every single coil experiment we do. And he uses fractions and he tells you how he uses them, but he's so excited when he does it. It just gets you excited to hear it. It's not like hearing somebody like a math teacher tell you your fractions, right? V Sears is into it, man.
Well, there's such good reason for that. First of all, his personality is there for it.
Yeah.
It's awesome.
I love that.
Secondly, I mean, when you sit through a math class, they tell you here's the equations and here's how you do it. They never tell you why. And that's the thing. Like even at college level, it's all about theoretics, but not theoretical application. You know, and here's where theoretical application is interesting. Just here's the equation, here's how you do it with no context or relevance. That's useless. You know, that's giving somebody a codex and saying, if you find these numbers interesting, then figure it out for yourself how this applies and how you could apply it. Like, cool and all, but really it's kind of not that interesting. And he went into the esoteric end of things too with numerology and gematria, you know, which if you ever go down that rabbit hole, let me tell you something, like you'll never look at a number the same ever again, like ever again. I'd been down that, and like I look at anything that I see like numbers, I'm always trying to find context and patterns of numbers and stuff, but I have to almost like stop myself from doing it because it becomes annoying. Like, and I'm not an obsessive compulsive person, so it's like, you know, anytime I find myself doing something without good reason, I'm like, dude, shut it off. You know. But yeah, the name stuff that he brought up and the birthday stuff, the numbers and how it all applies, you could tie that right back into the you know, gematria has a direct relationship with Kabbalah and the Tree of Life, which has a direct relationship with sacred geometry, which has a direct relationship with fractal patterns. You know, like the realm of everything I've been discussing is that it's all connected. So when I talk about relevance of a coil and how, you know, a black dot on a white piece of paper was the Big Bang that created the universe, and how the manifest of all this stuff, it's all because, you know, that's the cosmic scale. Then there's the macro scale, you know, like it's all relevant. It all plays a role. It's all part of the same exact little woo, you know, like that's it.
I just love it because he talks about the music in there too. And it's absolutely amazing. So when you go into a church and you see a pipe organ in one of these old churches, it'll absolutely start to make sense. You know what I mean? And it's just beautiful. It's like, I can only see his eyes, man. Like when you think about it, what he would feel standing in that church, because their numbers must be flowing through his head at that point in time, because he understands what's going on.
Yeah. That it's and then how that ties right into just spirituality largely, you know, sympathetic resonance, resonant tuning, how that ties into, I'm gonna fluff them up one more time. Joey was talking about it last night. He went and did a ritual, and part of that ritual was throat singing. And I mean, first of all, I love throat singing generally. Like, just, you know, there's like a band like called How Long, you know, they do like a lot of throat singing and you know, different harmonics and stuff. Besides the point, though, the throat singing, you know, not only projects, but it also vibrates your entire chest, your entire head, your entire outer aura and environment. You're creating your own cathedral with that type of singing right amongst yourself. When you go into that cathedral, first of all, the stained glass windows in old cathedrals, the way that they used to be built, okay, was emulation of the holographic nature of our universe, you know. And when the sun shines through, it actually projects that light, those images, into the being of the church. You have that and energy structure. Yeah, Helling's awesome. Like, can't even with them. So, then you have the architectural structure, which generally was built by the Masons, and the acoustic properties of all of those geometric shapes and formations, add to that resonance. And when I was talking with Gerald the other day about the Lake George mystery spot,
okay,
it's exactly like that. That's just an anomaly, whereas that is by design. Then you have the pressure of the organs and the differential of the pressure of the organs and the reverb. That's what'll really get you, is the reverb in there. You feel it in your chest. Once it starts taking you, you're gone. Unless if you stop it. Don't ever stop it. If you ever get that sensation of something like internal resonance that feels not bad, do not stop it. Let it go. Unless if you're driving.
Well, what I noticed,
don't let it go.
When they sing together, right? One person sings at maybe one tune, another person sings another tune, and then they all come together and sing, and it's a whole different sound that they all make together, right? But then it transmits back to each individual person and resonates through all of them. You know what I mean? That's what I find so cool about it. Like, you'll get a feeling of resonance when you're standing there and singing along with it.
Now, so that'll speed up the process because you're participating in that same energetic output that then is coming back, and it's from everywhere. But now put a different lens on it. Let's just say that you're someone that's not participating and you're just there. It will eventually overwhelm you. And and that's no different than what we were talking about before, about the power of the pressure differential. You're there, and guess what? It's more powerful than you are at that level. It will sync you up.
Well, yeah, especially if it starts to bounce around the room and bounce back to you. That, because you're surrounded in it. You know what I mean? And that's kind of one of the keys of all these churches and everything, is that you're inside the chamber. And you're picking up energy from everyone else, and you always feel like there's more energy in the room as soon as that starts. That's kind of what's crazy about it. It's like, I think somebody was mentioning earlier about a stadium, and it's like, well, open air stadium versus an closed in stadium, the whole thing is a bit different. You know what I mean? Your feeling in the indoor stadium is so much more like it hits you. I've been to a lot of concerts like that, where outdoors, not so much. I'm hard of hearing, but when I'm in the stadium, you know what I mean? And then it's rocking and you're all over it, man.
Yeah, but that's the difference between seeing like a concert, for instance, at just like any old hall or stadium that a band is traveling to, versus like seeing them at like an amphitheater, versus seeing the same exact band at like, I don't want to say like an opera house. That's a little extreme, although it falls in the spectrum of the same thing. But like, wherever I used to go in the city, I can't remember the name right off the top of my head, but I used to see Hot Tuna there all the time, right before Thanksgiving. But the point is that the acoustics and the harmonics in the particular building, like, it was built in a way to produce that exact effect. The ceilings, they weren't squared off ceilings or anything like that. They were purposefully, domed and pointed at certain different angles. They had balconies, and the balconies, they had, the little thing on top of it. Yeah, well, that wasn't. What's that? To keep you out of the rain inside, or to keep the sun off of you? Like, no, that's the so whoever designed it had all the acoustics in mind of that particular building, and that was necessary to avoid, audio refraction in that particular area. But it's like I said, the craziest thing about audio reverberance in any specific area is that anytime you have it directional, okay? Anytime you have it directional and it has a point of focus and a point of return, okay? If it's zeroed out at any point in time, you're actually going to have areas of amplification, areas of deconstructive, interference. And then if the world is the perfect circle, just like that spot on Lake George, there's also a certain point where you could sit there and scream your head off and it'll just sound like the world is shaking and you'll shake. But then there's that point where it's zeroed out and returned, where literally they could be 25 feet away from you and probably not hear you at all. It's just mind-blowing. And it's all going on in the coils. It's all going on in amphitheaters if it's happening, but they try to avoid that. They're trying to,
I think that's the difference of what we look for when we do experiments on this channel and Gerald's and everything else. We're looking for every anomaly we can find. Anything that everybody else drives out and like Steinmetz's and they kill it, but that's exactly what I'm looking for. Like they always say, well, when you mention Steinmetz and you put Tesla in the same sentence, well, why do you do it? Because Tesla found every anomaly. Steinmetz found a way to kill every anomaly, right? So what do you have to do? You have to understand both in order to understand what was left over after Steinmetz got rid of it. That's the part that we all know. The part that we don't know is the part that Tesla knew and that Steinmetz took out. So what did he take out? Everything he took out now I need to put back in. Okay?
Right.
That's the point. It's a process of elimination. And that's it. I'm going to find those anomalies again because that's what made him special. That's what I want to know. We're not trying to work on the same explosive energy. We're trying to work on the implosive energy. And if you're going to do that, you got to change the way you think about things. So,
yeah.
And I think there's more power in an implosion than there is explosion.
Oh, there absolutely is, because, an implosion is, pardon me. An explosion is restricted, okay, in the sense that it can only be discharged at the mass in which it is, okay, whereas an implosion and filling in the void, okay, is the potential of all the overwhelming power of the surroundings, which is usually greater in volume, so to speak, than the internal, which is the nature of the collapse. That's why cavitation is such a powerful force. That's why it creates the charges that it does. In fact, I had like a little mind thought experiment the other day. Just and it doesn't work. It's not the point. But the point is just, we look at energy production, okay, from an explosive manner, okay. That's exactly what you're saying. Well, I thought about it the way that you are saying, but I just put it into a different context, and I was like, it'd be interesting if you had a ball at atmospheric pressure that's designed to fail and come back together, and inside of the ball, is basically just a turbine generator with a wire running up to the surface, and it's designed to pop at a certain depth in the ocean. You just drop it, and it goes and it goes and it goes and it pops, and then all of a sudden you have all this implosive energy spinning your turbine. The implosive energy then, can be produced immediately into frequency and charge and be sent right up the wire, to its mothership or whatever. Now the trick to make that free is now you got to just figure a way in material science wise, again, where the differential between a sinking ball when it's filled with water under pressure, somehow then becomes able to be buoyant when it's opened, which generally speaking is a difficult task, because if it was sinking when it was closed, then it would absolutely sink once it's opened and neutralized to the atmospheric pressure of the sea, or the sea pressure, whatever. But then again, who's to say that you couldn't have like a high efficiency propulsion device bring it back to the surface that only takes half the energy that it created? Why not? I literally don't see why not. And then at that point you have a system that's closed, because it's creating enough energy to then sustain its ascension to the surface again, and then it would just fall, and then it would just come back up.
So let me ask you something.
Yeah.
All the energy that we seem to have in the air, do you figure that's explosive energy or implosive energy? We're just talking like stand in your front yard, you feel the energy from the sun, you know what I mean? Things like that.
Yeah. Is that implosive or explosive? I never thought about that. Let me think. Hang on. My gut answer, by the way, my intuition on it was neither. And I'm just following the paths. Hang on. Okay. Neither, because we are in a state of symbiotic neutrality and equilibrium, and the sun and its solar energy, in all its forms, because now you're talking about all sorts of shit. You're talking about light energy, you're talking about radio energy and radio frequencies, microwaves, the whole 9 yards. Okay. They are in a state of potential until they interact with matter at that point. And they reach a state of interaction when they start coming into our atmosphere, which is why we have some protection from like UVA, UVB, but they're not in a form of compression because of the equilibrium that's reached in the symbiotic nature of Earth.
So if I just said it on an electrical standpoint, would it then be a scalar effect on the inside that we're experiencing now?
No.
Okay.
No. And what we're experiencing is a convection effect.
Convection? Okay. I'm just trying to see where we're at, because I always look at it.
I make this stuff up as I go along. I never considered this. It just seems like to me, it says convection. I don't know.
I'm looking at it because I always said it was a, how is this? Time dilation is where we're at right now. We're not in energy usage. We're not in energy pulling. We're in a time dilation where we stand on the earth. Okay?
Absolutely.
So that's kind of one of the things. When you get out further, you have the Van Allen belts, and you have interaction between the sun and the fields that we put out from the earth, and then you're going to get a big field that's built in between. So it feels like there's matter in there. It's just a different form of it in the radiation that it carries.
Okay, so what you said is relevant to something that that we've discussed. So I want to tie it together for you, because maybe that was just okay. So earlier in this one, okay, I told you that that whole chart that I made, okay, I'm going to stop referring to it as the chart for people that never saw the chart. Okay, I made a chart that is the descent of energy to matter. Okay, and then matter's ascension into energetic fields of the anima. Okay, that's what that is. Fourth dimension ascension to time space. All right, that works off of the spectrum. that spectrum, okay, is time-like, okay, and space-like, okay. Now, the further you descend up and down that chart, okay, is the more time is affected and is a factor, and the more that space is a factor. See, space is not a factor to pure energy, because there's no matter what's space, okay? Transversely, time does not really matter to matter all too much, okay? It's only through the ascension of matter up through the chart again to the fourth dimension that space and time hit a plane of equilibrium where where space matters to time and time matters to space. Okay, this is what Bentov said. He has a chart that explains, and I should have sent you the chart. I'll probably look right here if I can find it. He's got a chart anyway where the further up or down you move on this, it's more space-like or it's more time-like. Now, I described a similar spectrum on the same exact chart today that said that things are either more energy-like or they're more matter-like. It's spectrum. So when in context, I said plasma is a matter-like energy. So it's an energy with matter-like properties. Whereas you have hydrogen on the other side of that with magnetism in between, hydrogen being matter with energy-like properties. Okay, so that's sort of the spectrum. Now, everything falls in the same thing. So the more dense, okay, the more dense an object is, and the less energy-like it is, okay, the less time matters to it. All right. And on the other hand, the more energy-like something is, the less space matters to it. So when you enter matter into a higher energy state by virtue of charging it with particles and trying to make it float in the air, okay, that brings it closer where space, okay, is less significant. Okay, but because it's matter, it would, when it accelerates and it travels through space, it starts to act more like matter, and then time matters less. So all of a sudden you have space and time mattering less because you have high density material combined with high density charge. It brings it to what I would consider to be the left side of the chart. I know I don't have a chart to show you at the moment, but it's like the left side of the chart where light's going this way, but then you're not even on that path anymore. You're on the other path because of the density of the matter combined with the extra density of the energy in that locality being higher pressure, but stable in a lower pressure environment. That's the key, the lower pressure environment. So, when you want to make things float in the air, you want to make things travel through space and time, high pressure existing stably in a low pressure environment, left side of the chart. So light's going that way, speed of light, all of a sudden you become way less subject to that because you're not riding the same line anymore. And that the Bentov kind of had that chart and I'm looking for it, but yeah.
It's
I'll
funny.
send you a picture. We could have it on the next one,
Yeah. One of the things somebody kept telling me was if you want that gravity flyer to fly, then you need to just hook it to a weather balloon. And then it'll rise, right?
I'm laughing. Give me that guy's address.
It was messing with me, right? But then again, I started thinking about, okay, so if I took a hot air balloon, right? And the only thing that I did to this whole thing was make it hot enough inside of a field on the outside of it. So it's the outside of the field had so much friction between the environment that it's in that it created enough heat to put a heat under it to raise it, then it actually would work. Okay? That's the only reason that you can get eddy current to lift aluminum, is that you're creating the heat in it, but it can't stay inside the aluminum. So what does the aluminum do? It repels it. So as it completely repels it, it's doing exactly what you wanted it to do, because you're creating a field around the aluminum itself, and then the heat itself is what's driving the lift. And they always say, well, it's the field of the amps. Well, what are the amps? The amps are just heat. Well, there you go. That's your answer, right? So I'm thinking to myself, though he was pulling my chain, right, to have some fun, there is an actual science to it that you could follow if you knew how to create the bubble. And that's really it.
Listen, I don't know if Gerald's in here or not, and I know you like cats too. It's not that I don't like cats, but I'm using a cat example, and it is about skinning them. Okay?
I'll talk to you that.
There's a book, and it's a satire book, and it's a joke, and I saw it and I did not buy it. Okay. That's called 101 Ways to Skin a Cat.
Okay.
The one that caught my attention was when they turned the cat into a pencil sharpener. I was like, oh man, I'm glad he's a skin cat, not a real cat, because man, that cat wouldn't have been a happy one. Yeah, probably hit the ceiling faster than throwing him in a bathtub.
Wow.
Yeah, but that's the point. Point is, yeah, you know what? There's so many different solutions to the same problem. And the equation of the logical equation, not the number equation. Okay, the logical equation is always going to follow the same path of the interactions, you know, and the context, you know, and the atmosphere and the dynamics at play. You know, if you're looking for certain effects and it's under certain environmental conditions, like you well know, when it's, you know, sunny and humid, right? Or if you're ascending through the atmosphere and you're in, you know, a less dense mass state at that point, and you're starting to get into the realm of, you know, the upper atmosphere and the stratosphere and stuff, where, you know, there is that point in time where the atmosphere and the and space are gray. You know, it's a gray area, and that there's forces going on there. It's the forces we've discussed earlier. You know, so the context of what you're trying to achieve, how you could achieve it, could be 1,000 different ways depending on where you're looking at it. Like, you know, is it? And I ask you this: is it the same at sea level as it is in the mountains?
I don't know. I don't think it would be, but then I haven't tried it.
So, you know, I mean, you have altitude where you live?
No, not at all.
Not at all. Yeah,
I'm in the valley
either.
I'm in a valley, so
okay.
But I'm next to an ocean, so it's I don't know if we're under it or just a little bit above it, but I know if they break those mountains that right, you know, over one side and they come over that a bunch of stuff, we're done for. So I would say I'm pretty much at sea level or close to it.
Okay. So, you know, so your baseline is 0, which is easy, but you know, like if you know, you could take your very setup that was working and under the same general conditions, humidity and temperature, whatever, but then you go, you know, up to 2,500 feet altitude. I don't know, because the density, because the pressure equation ratios have changed. You know, it brings to mind right off the bat, you know, it goes right back to the first time you and I spoke. I told you I had that Dremel and it changed, but that was the rock, whatever, not what I'm talking about. But what the Dremel does, is it sees a change in load, and then it adjusts for the change in load. So and until it finds the equilibrium of its setting. So, it's one of those considerations, because, there's always the thing, I know the thing floats the way that it's worked out, okay, so now what? Like that's the step 2, I guess, like, because does it fly today and not tomorrow? Does it fly here and not there? Then how do you overcome those obstacles? None of this is a problem in outer space. Well, if you're in outer space, we're not talking about Graviflyer. We're talking about thrusters and bending time space. Yeah, that's all you care about then. That's all you care about.
Because the other's irrelevant.
Right.
So I honestly do not think it's something that translates as much as I'd want it to out to space from the ground at all. I think it's a proprietary system that stays inside the Earth and only at a certain level, because it's not built for the complexities of switching. You know what I mean? It won't handle it. It's built to be at low levels, not at high levels. The extra energy may just throw it completely out of balance, because as soon as you hit the upper atmosphere, the amount of energy you're going to get in that thing is going to be massive, and it'll just take it out. I don't think it's built for that. So because it has no outer shell, there's no way to compensate for that in what it is. So if I put an outer shell on it now, it'd be much more capable of transversing the area between here and outer space. But without that shell, it can't do it.
Right.
It's a field generator that picks up a specific type of energy that makes it lift. It is not an anti-gravity fully craft.
Yeah.
There's a difference in the two, and I already know it. I've already seen the energy and the way it passes through it. It's not going to work in the way that most people would want it to somewhere else. It's a means to an end, and then you have to find the solution somewhere else. And I believe I understand what it is, but it's not.
I'm thinking about something that I don't know if you could tie it in. In my head is saying that it's related, that there's relationship, but I just haven't connected it yet. So maybe help me.
The relationship is the field it creates is absolutely important. And the Tesla field that it creates that holds in the other field of energy has to happen.
Right.
The problem is there's no zone in it to have a time dilation zone. See, because as much as you want to create a craft that's on its own, it has to be built like a magnetosphere in order for it to exhibit the parts you need in space.
Well, I mean, again, only an opinion, just my idea of how it would ideally work with time dilation being a factor, a controllable factor, would pair back to the idea of the exploiting the 0 point kind of in similar fashion to how I was saying, because you got to be able to keep that open, and if you could keep it open and expand it by expanding the load, and then being able to pull I don't know what else to call it, because it's not really, but it's analogous to like an arc, right? So consider your portal area, an arc plane of scalar interaction, whatever, right? You up the input, and then when you pull it apart, it's kept together with extra load. It's a bigger area. That's a zone of complete time dilation. So how that, and I mean, I'll throw it out. I mean, I haven't followed the logic here yet to say, well, this is what I think and this is why, but immediately where my mind goes with it is that if you have a zone of interaction, there's also gradient effect of if you're dilating time. So if you're dilating it in a point this big, there's going to be effect of the time around it, which is at the pinnacle of that being the highest effect. So I think and then it's powering the craft, and then it's disconnected, and it's a free flowing system into it. So it's got locality. I don't know. That's where my mind goes with it.
Let's go back to the null zone that we say we're standing in, right?
Yeah.
So if it was a zone that carried energy in it, okay, then this thing would have a chance, because this thing uses the energy and spreads it out, and it gets it at scalar state because of the distance of the plates. Then it's subject to any extra energy throwing it right out of place. But it does need that null zone. In order to create the null zone, you must create an outside of the craft. You know what I mean? You have to create a shell upon it in order to create the null zone. That way, you cannot be affected by the rest of it. That's why I say this craft doesn't have that. So it may reach a certain level of lift, but that's it. It's done, because it doesn't have that null zone in it. And we already know we're supposed to have it, and it doesn't. It's based on an energy that's pulling to an anode and cathode so far apart that it produces a certain type of energy. But when you nullify that with energy from wherever it is, you ruin it.
Do with this analogy what you will, but this is what came to mind before I kind of went off on it.
Yep.
But have you ever noticed, like, if you take a hot pan, like the steam effect, where, like, if you take a hot pan, you put a drop of water.
Yes.
The pan's hot enough to boil the water, creating a steam barrier between that and the drop, but it doesn't have enough energy to boil the drop. So what ends up happening is there's no direct contact with the water and the hot pan. Okay. But because of that bead will fly around the pan like a superconductor. It's just inverse of a superconductor. It's inverse because, obviously we know that there's ways to overcome, theoretically, superconductivity. We've talked about it. Besides the point. I'm talking about what they present as superconductive properties under super chilled conditions. It's the inverse of that. That's all it is. And the relevance of the slip that's created between a matter and energy field. Slip. That's the word that's coming to mind for me, is slip. Because that's what it does. There's a steam layer in between the hot pan and the bead of water. The bead of water isn't enough to cool down the hot pan below boiling point. And there's steam, and there's not enough water in order for it creates the steam, and it slips around like crazy. It goes crazy. It's like, and it's a bead of water in the pan.
Yeah.
It's going hundreds of miles an hour off of contact because it's slipping. It's slipping because it has no contact. Yeah. And that's the exact dynamic I've been trying to articulate. It's just so oh my God, it's always just there. It always just comes back. It's this differential between the energy and the matter. It's the differential. It's the pressure energy. You have a low pressure system in between a mass that isn't boiling because it's just simply not hot enough, except that at the surface level it creates a barrier between point A, point B, and it slips. And there's just simply not enough energy to boil off the bead fast enough if if you think about it that way. And if it's moving, there never will be.
Yeah.
Yeah, it's all interesting stuff.
Well, you mentioned superconductors, so let me say this. So we're looking at Gerald's coil and stuff, right? And the way he built it. And he's getting so much energy in the center because it's so cold. Now, one of the things about the superconductivity is they have to cool down everything in order to get it. But when you're building it and it's not just chilled and put somewhere, you're actually going to have heat on the outside that allows it to rotate. So the magnetic field itself in any coil that you build, no matter how you do it, there's always going to be a barrier at the side. So when you get to the end of the coil, there's a barrier, right? That barrier is caused by the magnetization of that coil that pushes it out. So everybody thinks the field light comes in and goes back in. Well, it may try, but why does it get straightened back out? It's because that magnetic field pushes it back out. So that's why it can't come back into the coil. It forces it back down and goes to the bottom. That's why it loops around the very top to the very bottom, or the very bottom to the very top, however you want to say it. It's making that looping effect. That's why.
Well, that should have a vortex then, because of the counter rotation. It should create a vortex.
That's correct.
It's got counter attraction and counter rotation. So
it's got a vortex, and it's super cooling, just like a superconductor. That's how it picks up the energy. Yep. It's creating a superconductor. Now, is it anywhere close to the coldness that a superconductor would get? No. But is it getting there? Yes. You see, when you drop like 30 degrees in the center, okay, then you know you got something big. My gravity flyer on itself drops 20 degrees. It right in the dead center, it gets cold. But on the outside, it has heat. So it's forcing things to go around it on the center plate.
Well, the temperature is only relevant because of the molecular movement at similar temperatures. So when you have two different, again, this is right out of my rear end, right on the spot. I don't know where I'm getting this from. So when you think about it, if you super chill down two different materials to the point where their molecules are moving at the same or similar rate, then they're going to lock, because that's the deal. They've reached equilibrium, the same exact equilibrium of why the Earth is locked in a certain orbit with the sun, because that's the space of equilibrium. And evidently that's the same thing logically as the bead of water in the pan, because there's the equilibrium is reached with the hot pan and the steam in the water, creating the barrier between the two. That's it.
But that's
it's more visual when it's hot.
But that's how we know we're on the right track.
Yeah.
We're recreating what our Earth is creating. You know what I mean? It may not be to the scale of it yet, but that's what we're doing. So we know we're heading in the right direction. That's kind of what I'm getting at here. We're absolutely there. We're hitting the right thing. We're not on the outskirts. We're not looking in. We're there. We're at the point where we should be in order to learn it. And it has to do, the reason that his coil's working the way it did, it's because he found all the instabilities of it that Steinmetz would have got rid of, and that Tesla would have kept in. And by keeping the stuff that Tesla would have kept in, now we're getting the effects that Tesla talked about. Now we're starting to reach where we need to reach it on a higher level. You know what I mean? That's kind of where I'm going with. There's a whole understanding to it that people got to understand. That's why I always tell people, if you're looking at AC and DC and you think it's just pure energy and that's only where it comes from, you're in the wrong place, because that is not how you got to see it. That's like high school level. You got to get up further.
They don't even teach us that well in high school. Let me tell you something. I went to school 1 year, vocational school, to learn how to do electrical work. For the first year is residential, the second year is commercial. First of all, I absolutely hated it. Okay, throwing it out there. That's why I didn't do it. I ended up doing 2 years of welding after that. Case in point, even what they taught you when they're teaching you is none of this. Okay, and all they care about teaching you is how to run wire to code, what a circuit can and can't handle,
Yeah.
How to adjust your circuit to handle what you need it for. Okay. And how to properly wire a basic household circuit. Right. That's it. And I'll be glad for one reason that they do residential before commercial as to why I quit, because I wouldn't have been happy doing it, is once I was like, wait a second, I need to bust up drywall and sit there and snake wires through, if you know, and all. I was like, yo, I'll run electric all day. I was like, I don't want to sit there and have to figure, destroy crap and figure out how to run it and run into all sorts of problems all the time. So I got deterred from that because of that reason. I was like, this is 80% of the job is literally tearing open the wall and figuring out how I'm going to get it going. Like, I'm good on that. So I went into fabrication, which was far more beneficial for my overall aptitude, I think. Nonetheless, they don't teach any of this. They'll teach you Ohm's law, they'll teach you about voltage and amperage. That's about it. That's what you get. And guess what? You could leave there and, go work as an electrician. They'll give you a certificate, which is your free pass to go get a certification if you wanted to. Right off of that, with no further knowledge. That's what you're dealing with. So, I don't know. And obviously, that's not electrical engineering, but these are people in the field working with the stuff, and this is what they teach when it's specialized in that. You go into the science class that I didn't have to attend because I went to that school. Like they're going to gloss over this like one chapter and you learn the answers to the test. Like that's the extent that people are thinking about this most of the time.
Yeah.
They're not breaking it down any further. They're not realizing what it is or where it goes. They teach you that wire flows through wires. They teach you that electric flows through wires.
Wow.
That's what I'm dead ass. Like I came out of that school believing that energy flowed through a wire like water does a hose.
They didn't understand the compression of the insulation around it that's causing the heat.
We didn't the only context with that was with regard to current amperage and wire gauging, because it was only the Ohm's law and the resistance of your runs, because it wasn't about understanding necessarily the physics behind it. It was only to understand, like, here's your equation if you need to run this much. If not, you run into a short potential because you're overloading the line, and you're going to run into heat due to resistance. If you run too much current through like 16 gauge, like 16 gauge or 18 gauge or something, it's
always been so strange to me how an electrician wouldn't understand that when you go to volts and amps, heat creates amps. So why they never understand that, it blows my mind, because as soon as my breaker goes off, it's because I heated up the line. Means I put too many amps in it, and my breaker's only qualified to handle so many amps. And when that thing blows, that's why. It just
right. Well, you put too much of a load, you drew too much, which would have overpowered the wire resistance of the system.
That's what hold on right there. Just what you just said is the reason they probably don't understand it.
But guess what? That's not what I came out of. I can't talk for what electricians know or don't know generally. Like, I'm sure that there's all sorts of minds out there. But like coming out of that class, I didn't know any of that.
But what I'm saying is they always try to tell you the solution to the problem, and never figure out why something is happening the way it does. So they never stop to look and say, hey, if I got heat, I got more amps. They just told you how to fix it. They just told you then don't plug in your printer over here because it draws too many amps, right? They didn't bother to tell you that, hey, once it heats up, you got more amps and it blows your breaker. You know what I mean? You got your load's wrong for it. That's all they tell you is, oh, it's about the load. It's about the load. Change your load. and you'll be fine. Well, really? Because I could sit there and cool the lines and it would do the same thing. It'd run just fine. You know what I mean?
But therein lies the difference between electrical engineering and electronics versus household electrical or even commercial electrical for that matter. Like, it's not efficient. It's not an efficient way to go about it to cool lines when you could just simply throw another breaker on there and be like, don't, let me run another outlet. Like that's sort of, or, oh, look, I got a 15 amp breaker in here or 10 amp breaker in here. Let me put a 15. Well, it'll be fine, whatever.
It causes problems when you get into stuff. Then you want to say it's an amp motor, right? And all it produces is amps. So you spin a big neodymium magnet around one, and then what does it do? If you take the pole it's sitting on and the magnet, it's creating an amp motor. Okay, that's all it will do is produce a ton of amps at very little volts. And they say, well, it's useless. It's useless energy because it's all amps. Well, not really. It's your understanding that's useless. Now all I have to do is cool it slightly in a simple transfer. And then I now have volts and amps. And I can equalize.
Yeah, I mean, they interplay, and that's the whole thing too. But for anybody that says that, having high amperage is useless, I mean, tell that to a Mack truck going 5 miles an hour and you refuse to move because the Mack truck is useless. Like, I hate to tell you, but it's going to knock you over. Then it's going to crush you. And then it's going to crush you with some more wheels. And then, it's got some more wheels, just, and the thing loaded up with the, refuse of like cement and stuff. And guess what? Like you never stood a chance from the get-go, all because the volts weren't there. Right. Would you be more scared of a Mack truck going, 300 miles an hour? Well, I mean, I'd love to see that first of all.
Yeah.
But
it also explains why some people could take mercury as a transfer of energy from amps and just cool the mercury, and then it starts producing volts and amps.
Mm-hmm.
And it's a beautiful thing to see if you understand how to do it. And a lot of people don't, and they're starting to transfer stuff and move things. They make a whole big process out of nothing.
Well, you talked about things being illegal. I think that's one of them. I think that's one of the things. Yeah. Like I think that they say no to mercury motors.
Yeah. Well, that probably, it is. I think you're right. But
some people I think that's one of the things on the list. Yeah.
I've seen some people use mercury in there in order to, just get an over unity effect out of the motor, or they get voltage and amps. It's useful with something that's very simple to, turn. It doesn't have a lot of resistance to it. So you're over here turning this thing with this RC motor and it's producing a ton of energy. And I mean, technically it's over unity, but it's just a smart way to honestly run this thing.
Yeah.
Why you go over there and fight against itself when it doesn't have to?
Resistance is futile. No, but in all honesty, overcoming resistance is you figure that one out, you got it. Got it all. Obviously. But
they've already figured it out. They just don't know how to transfer the amps to volts. They haven't figured it out. They haven't figured out the heat and cooling system. It's like, for instance, if I go and take a lighter and I put it in the middle of Gerald's coil, it changes the volts and amps real quick. Immediately. As soon as I do it. If I change the frequency.
But if you have the thing running and then you capture your amps, then you just all you really need is transformer,
That HPG first motor generator discovered by Faraday. Absolutely. It's exactly what it is.
I've seen that before. Yep. It's cool stuff. By the way, when I say illegal, I want to be clear on this. When I say illegal, it's illegal to manufacture and sell. If you're, it's not illegal to do this and then just have it. They don't want people producing that and selling it.
Well, because mercury's bad for you.
Clarification, there's laws all affect people differently. It's not about the possession, it's about the production and sale. Production with intent to sell. Yep.
Sorry, I go in more of the aspect of how things are built, because it drives me nuts when people don't understand something so simple, and you try to explain it to them and they're lost in the weeds. And anyway, that's just my perspective on it. But
hey, man, some of us are just lost in the weeds all the time. Just saying. Where'd you go?
Well, I was doing it with my high voltage in my garage, man, and I start playing with it, and you notice the difference when you start changing everything, right? So I want to just create plasma, and then at some points I just want to create pure charge. And how did I do it? How did I bridge the gap? Well, all I did was bring up the frequency, and it brought down my amps, and it took my thing from a state of plasma into a state of charge. What did the charge use? Charge created pressure, and it creates an intense pressure. So it's charging everything in its vicinity around it, the air, the paper, everything, and it's forcing it down. And you get a much higher amount of force on a scale than you would by putting something else into it. And that's the beauty of it.
It really is. When the systems all work together, you get exactly what you're looking for.
Yeah. It was just a simple understanding that fixed it. And so anyway, that's just mechanical perspective. I like to build things and what I mean? Stuff like that.
Yeah, I'd love to see a little future thing on here with me, Gerald, and Victor, if we could be willing to get the heads in one place, because I just think that it would be just such an interesting dynamic. What I loved about Victor's work, not to go off on a sidebar tangent, but is that it's like all of like the processes, he was able to put the numbers to it, and those numbers are important, because as much as theoretics will get you, theoretics leads you down a path of trial and error, whereas understanding the numbers associated with it will make you be successful and make smart, intuitive, and successful systems more readily and frequently, and it'll allow you to be able to say, okay, test. This is what the numbers should look like. This is what the numbers look like. And then go back to the theoretics of it and figure out, what's got to be moved.
Well, it's just Monday's kind of a hard day, I was going to say, to set you guys all up together. But that's because you said you were busy on Mondays.
Yeah, Mondays are tough for me. That's the hard day.
Maybe Wednesday might be better.
Yeah, Wednesdays are good for me.
So I think what I should do is, I know Gerald's going to be there. I know V. Sears always checks in, when we do Mondays and Wednesdays. So I think that'd be the day to do it. And we just kind of push the circuitry stuff to the side for a day and let you guys have at it. And I'll sit in the background and just pull things up for you guys. And I think it would be an amazing conversation.
Yeah. I could only imagine where it would end up, frankly. I wouldn't highly expect that to stay on this particular subject for all too long, and probably bounce around a little bit. But
I think it's going to bounce everywhere. That's the beauty of it.
That is the beauty of it. Yeah. And
I mean,
I always like the nonsensical fluidity of these conversations, because it's like you could go all over the place, but the transitions between them are generally not super abrupt.
Man, I could talk about we were a burning show, and you and Gerald, man, we could have let you guys go for hours. I mean, that's
super rude on that, by the way. It was retrospectively realized I didn't realize I hijacked. Like, Bernie, if you're there, listen, I apologize, because I legitimately inadvertently hijacked your show. And then, once me and Gerald started playing off of each other, I was like, Nathan, pull up this. My sincerest apologies, because frankly, I love his work, and he's such an interesting guy, Bernie, and such is so on point with so many things. And then he was playing Sheila. And honestly, if I owe anybody an apology to, it's her, because she is a brilliant mind, that woman, Not hard to look at.
Absolutely. Yep. Well, I think we'll do that. Let me talk to Gerald. Maybe we'll set it up for the Wednesday. Because I'll talk to V Sears as well. But I think we can set that up and then just go, crazy on it. And we'll just pull the circuits for another week. And then we'll probably do it on on a Saturday or a Monday. But I think Ian will have to be involved in that conversation as well.
I would say that there's not a single person that's part of this community that ought not be part of the conversation at some point in time. Like I said, everybody's just super interesting and whatnot. I just happen to know, it's like, oh, okay, where I'm coming from, this plays off of this and that pretty intensely. It'd be interesting to see where the conversation goes. Well, I'll tell you honestly, what, these things pull my mind open in a way that's just
I'll tell you what, because Ian wants to see the builds, so maybe we'll do the first 30 minutes of the builds and then let you guys have at it. You know what I mean?
That's what's up. Yeah.
That'll probably work out. That'd be pretty, because everybody likes the simple builds. And I know I was working with Sean as well, just to understand MOSFETs and transistors is a big thing for people, just so they can build the stuff that they want to build. So I know we're going to have to get into that in future episodes, but yeah, I think Ian's right. Just a little bit of that, a lot of this, we're good.
That's why when I do my channel, it's going to be a little variety, because it's going to be edited, because I could go on for 3 hours without batting an eye, bounce around. It's little self-awareness and trying to be so when I do my channel, just so everybody knows, edited content, not super duper scripted, because I really can't, but it's going to be structured in terms of a script, so I could get through it. And then it'll be a little free form with the interviews and stuff like that, and kind of funny. But I think that for me, the key point is it's not going to be like this, where it's 3 and 4 times a week, or whatever. It's going to probably be more on a 2-week, schedule, 45 minutes run, good. Start to finish, compress it. And honestly, I feel bad for the people that have chosen to be in my life super closely, because frankly, they have to deal with me all the time. So, limiting your exposure to me for 45 minutes a week is probably not that bad.
Well, they're all going to have to deal with it, man. We're starting a community here, and we already got a lot of great people in it. You know what I mean? So my family has to deal with it all the time. So it's too bad for them. They're just going to have to live with it. I had to live with all their stuff for all the years, growing up and everything else. So now they get to deal with mine. So
that's it.
That's the way it works.
And it's all been peace and love here. People are trying to help people. That's what it's about.
Okay, yeah. Ian said, sorry, I'm reading this at the same time I'm listening. Great, thanks. I sometimes have questions in the last session. The connections were not explained. Yeah, that's absolutely true. I've had new coils to break through Gerald circuits. Yeah, that's exactly what I want to get at. So that's kind of why we're
not doing for anything. That's what I want to see.
Well, yeah. That's kind of where we all are. You know what I mean? He's got the information. We just need to put it into our stuff, because we're all doing the same thing.
You see, I'm a little bit of a dick, though. When I was talking to Gerald, I knew exactly what I was doing. I was probing.
Oh, I know what you were doing. Don't ever think I don't. I know who
it's friendly and subtle, and he could just shrug his shoulders and be like, I don't know, but it's yo, give up the goods, brother. I know you have in your garage what I know in my head.
Yeah. Well, let me just say it this way. I let Gerald do his thing. He's going to release things as he only wishes to do it. Not because of our pressure or anything else.
And I wouldn't want it any other way. I wouldn't want it any other way, man. He's such a stand-up guy,
Oh, I hear you. Oh my God.
Amen, man.
I can't even understand that hardly. What does that say? Sorry, the lowercase and uppercase.
He says, "I hear you, Nathan. I raised 4 kids, and now it's my turn. Love, Gerald."
Okay. Gerald's got caps going. Oh my god! It was like I was reading Greek or something. I was just freaked out. I'm like, what does this say? It didn't make any sense to my brain. There you go, Gerald. You got me for the day. Wow, that was bad.
All right. Does anybody have there been any questions or anything like that for my retardation? Because if anybody doesn't understand the stuff I'm talking about, please. I'm happy to.
Oh yeah, absolutely. I think we went through some of the stuff that was in there. I don't think there was a whole lot more questions about it.
No, that's cool. There generally isn't when I talk.
Freaked me out with those caps, man. Oh my god. Yeah. I think it's funny, man. So I always say this. I think Gerald has something so unique, and every time I see his channel, it's like I have to figure out what he's doing. But in the end, I know I'm only hitting 80% if I'm lucky. Okay. Some weeks I might be hitting 40, but I always look to see if he says anything in return, right? Because, hey, you might be on the right track, you don't. And he absolutely gives me no clue whatsoever. He is never tells me, yeah, that's what it is. It's so, he's doing the caps again. Look at him. Oh.
It does.
Like a ransom note.
Yeah, it does.
Oh my god. I have fun with him, man, because it's just a hilarious conversation anytime we get together.
No, it's an amazing crew. And with everybody's permission, once I get everything up and running on my channel, I was telling you about my little puppet show that I want to do. Oh. I want to make a puppet show of everybody, just satire. But everyone's got to be a good sport because, like I said, I can be a dick.
Yeah. Oh, Gerald and his cats. Oh my god. Dude, last week he had the cats on, and as I'm explaining something, you see the cats pawing at the screen trying to get everything that was on there. Oh man, it was hilarious. But I liked the puppet show idea. I thought the same thing with the guys. I told them we'll just do a little Star Trek type of thing. You know what I mean?
Uh-huh.
Where we're driving around in a UFO trying to pick up Terran Earthling, and we can't always get them because Mike works the transporter. And every time we ask Mike a question, right, he starts going on and won't stop, right? And then, it goes, the voltage goes in here, and then we had the current, and it goes in here. And then you go, okay, Mike, let me check back with you again. And we come back to him, he's doing the same thing. And it's absolutely a hilarious joke. Where Gerald's over there is the engineer telling Ian over there, top of the morning to you.
I'm telling. So what you're saying is exactly what's going through my head, with this puppet show, except you're all on sticks.
Yeah, exactly the same.
You're gonna have Ben with his lab jacket and stuff.
Oh my god, dude, that lab coat is absolutely hilarious.
Yeah, I love it. I think it's awesome,
dude. Just the back of it, because I always see the back of it. I need to get him like a face or something of his face on the back or his logo or something.
Well, he's right. It's a white lab coat, so it's just kind of it's well, where's Ben? Where's Ben? Oh wait, there he is. So you got to look for the jacket, back of the jacket. But no, man, I think that's awesome.
Man.
It's really good. He's a great personality.
Dude, Ben's hilarious. He cracks me up all the time, man. Oh.
Sometimes I see stuff when he's doing with the goal. I'm like, no.
I think he's doing it on purpose to mess with me, man. Every time he does it. That's why it's so funny.
But I'm sitting there, but I'm not on the show, so I'm just sitting there looking at my screen going, no. But then he gets it, I'm like, yes. Very suspenseful. I love it. He's on to it though, man. He really is. His work is so nice. It's come so long too. So far rather. In such a short period, Yeah, I got turned on to him from Bendel's work, and I absolutely love Bendel's work. I could talk about his stuff all day, just because I think that was one of the first systems along this, train of thought that like I intuitively understood exactly what it was doing, and I was like, yeah, that's good. And then so I got turned on to Ben's channel because he was talking about that. Then that's how I found you.
Oh, right on.
Yeah, I didn't used to think about this crap before like 3 weeks ago. I have a very high potential aptitude.
Yeah.
It's just what it is. Yeah. But and I'm very glad I did. And thank you as always for having me on.
By the way, just before we go, I just want to show you this. Acoustic pushes the electricity just like the high voltage is triggered by lower voltage.
Mm-hmm.
It when I tell you that there's the energies created in the resonance, not in the power that you put in, it's exactly what I mean. He's absolutely got it right. So anyway, that's it. Hey, thank you for coming on, Joe. This is an awesome show, brother.
Thank you for having me as always.
Gonna have to do it again.
Before you cut it off, let me just give everybody watching the throat singing that once you hear it, you're gonna have to sit there while you're like, in the bathroom hiding from everybody. Like you're gonna try it, and if it's gonna come from your subconscious. You're gonna be like, wait a second, can I even make that sound? And you're gonna do it, and you're gonna be like, oh wow, look, you see, you have to get that.
Yeah, your camera doesn't like your throat singing.
Well,
they cut off on you a lot, but I know exactly where you're going with it.
Right. I think the table was shaking, the camera was shaking. That's the point of it. That's my head. I could feel it in my forehead. All right. So remember while you're sitting on the toilet, do some throat singing, have your wife check in on you, tell her you're not choking, and then return to your zen.
I'll tell her that's just what makes it move. So
that's it. Well, honestly, if you hit that brown note, maybe it will.
Yeah.
Right? Wasn't that a thing? Like, didn't the government try to like shoot brown waves into people to make them shit themselves?
Oh my god!
You know what it reminds me of? It reminds me of God help me. You ever see Howard Stern Private Parts?
Yeah. Oh no! Oh, I do remember that.
Yeah. Turn your treble down and your bass all the way up, baby.
Oh,
anyway,
that's amazing.
Yeah. All right. Well, now you got to see a little of my personality shine through. Now I'm not talking about nonsense.
All right, man. It's great to leave it on a good note. Have a great day, guys. Thank you all for coming in.